Hello everyone and welcome to the very first chapter of our ClickHouse Mastery Program. I'm your instructor from Durga Analytics and I'm really excited you're here. We're not just going to learn about a new database. We're building the skills you need for real, production-grade, unbelievably fast analytics. So, let's get started.
First things first, you're now part of a full production-grade training program. Our entire goal here is to get you way beyond just the theory. We're here to equip you with the skills to truly master ultra-fast OLAP analytics, build out tough, resilient distributed clusters, and engineer real-time data pipelines that can handle pretty much anything a modern enterprise can throw at them.
And this isn't just a one-off. This is a massive, cumulative curriculum, 340 chapters in total, designed to take you from wherever you are right now all the way to expert level. We're going to cover absolutely everything. Deep architecture, advanced SQL, all the way to production integrations with tools like Kafka and S3. But you know, every great journey has to start with that first step. And for us, that journey begins right here in Module 1, ClickHouse Fundamentals.
And that brings us to our focus for today, Chapter 1, our official introduction to ClickHouse. Now, a little heads up. If your background is in traditional databases, think Postgres, MySQL, that kind of thing, get ready for a pretty major paradigm shift. Things are about to get interesting.
So here's our game plan. We'll kick things off by understanding why ClickHouse is such a different kind of database. Then we'll look at the exact problem it was built to solve. After that, we'll uncover the secret sauce behind its incredible speed, and finally, we'll help you figure out if it's the right tool for your specific job.
All right, let's jump right into Section 1, a new kind of database. We're really talking about a fundamental change in how we approach and process truly massive amounts of data.
So what is ClickHouse really? Well, that definition on the screen is your key. It's a high-performance, column-oriented, distributed analytical database. But the most critical term there is OLAP. That stands for Online Analytical Processing. This is super important. It's not for your everyday transactions. This is a system that was purpose-built for one thing: analytics. For asking huge, complex questions of your data and getting answers right now. And this technology wasn't just invented in some lab. It was literally forged in the fires of a massive real-world problem over at the tech giant Yandex. They had to power Yandex Metrica, their web analytics platform, which was dealing with just staggering amounts of data. They needed a level of speed and scale that, frankly, just didn't exist yet. So, they built it themselves.
And that brings us perfectly to Section 2, the big data bottleneck. This is that breaking point. That place where the traditional databases we all know and have worked with just start to crumble under the weight of modern analytical queries.
Just picture this. Your boss comes over and asks a question that sounds simple enough. Hey, can you tell me what the total revenue was last month? And then they add, oh, and that's across our 500 million sales records. This is a classic, high-stakes analytical query.
Now, if you try to run that kind of query on a standard transactional database, you already know what's going to happen, right? The system immediately starts to slow down. That query timer just keeps ticking up, seconds turn into minutes. You're just stuck there waiting. And more importantly, the business is waiting on you. That is the bottleneck we're talking about. So that brings us to the fun part. Section 3, ClickHouse's secret sauce. How does it take that very same query, the one that crippled the other database, and give you an answer almost instantly?
The answer starts with just raw, mind-bending processing power. A single ClickHouse server can scan up to 2 terabytes of data per second. Let that sink in. 2 terabytes of data every single second on just one server. This is a scale of performance that really changes the game. To put that into perspective, ClickHouse can churn through 1 billion rows of your data faster than you can finish reading this sentence aloud. Seriously, by the time I'm done with this sentence, it could have already answered that 500 million row query and then done it again just for fun.
So I know what you're thinking. That just sounds like magic. But it's not magic. It's just some really, really brilliant engineering. So let's break it down. How is this kind of speed actually possible?
This slide right here shows the absolute core difference. On the left, you've got your traditional row store database. To get the total revenue, it has to read every single piece of data for every sale, the customer's name, their address, the item ID, everything, just to get to that one little number. It's incredibly inefficient. But ClickHouse on the right is a column store. It does something much smarter. It completely ignores all those other columns and reads only the single revenue column it needs. This one trick can reduce the amount of work it has to do by 90% or even more, right from the start.
Now that columnar storage is the foundation, but it's really only the first of 4 pillars. It's combined with something called vectorized execution, which processes data in big, efficient chunks instead of one value at a time. Then you add in aggressive data compression, which means there's way less data to even read from the disk. And finally, you have massive parallelization, where it uses every single CPU core available to work on your query. It's these 4 things working together in perfect harmony that create that incredible performance. Okay, so this brings us to our final and maybe most practical section for today. With all this incredible power, is ClickHouse actually the right tool for your job? It's all about matching the tool to the task.
ClickHouse just shines in certain areas. I'm talking about real-time BI dashboards that actually need to be real-time, or analyzing just enormous streams of logs for observability. Companies like Cloudflare and Uber use it for this. It's also fantastic for building huge data warehouses on a single server, or for powering ad tech platforms that have to sift through billions of impressions every day. And this slide does a great job of laying out the trade-offs. You use ClickHouse when you're analyzing trillions of rows, and you need answers in milliseconds for your dashboards. But, and this is a big but, if your main job is doing frequent, small updates, like changing a single user's password, or if you need really strict transactional consistency, well, a traditional database is still the right tool for that specific job. It's all about using the right hammer for the right nail. And that's our introduction. We've covered what ClickHouse is, the huge problem it solves, and where it fits in the data world. So what's next? Well, in Chapter 2, we are going to dive much deeper into the technical battle of OLTP versus OLAP, and we'll explore exactly why these systems are built so differently from the ground up. I really look forward to seeing you there. All right, welcome back. I'm your instructor from Durga Analytics. In this session, we're going to tackle one of the most fundamental concepts you absolutely must master to build production-level data warehouses with ClickHouse, the critical difference between OLTP and OLAP systems. Just so we're all on the same page, we're in the ClickHouse Mastery Bundle. This is Chapter 2 of our very first module, ClickHouse Fundamentals. And trust me, the concepts we're covering here, they are the absolute bedrock for everything we're going to build later on, from distributed clusters to real-time data pipelines. So let's get started. Let's start with a really core question. Why isn't there just one perfect database that can do everything? Well, the answer is that the database world is fundamentally split into 2 very different camps, 2 totally different philosophies. Every system you encounter is built for one of 2 things: processing transactions or performing analytics. First up, let's meet the bookkeeper of the digital world. This is the philosophy behind what we call OLTP systems. Think of them as meticulous, super fast, and laser-focused on one task at a time. So what does OLTP even stand for? It's online transactional processing. And really, the name tells you everything you need to know. These systems are all about processing a huge number of small, individual transactions that are happening like right now. They're the operational backbone of pretty much any application you can think of. So what's really important here is how all these characteristics work together. The main goal is speed for small updates. You know, like an e-commerce checkout. When you make a purchase, the system has to instantly update the inventory, process the payment, and log the order.
Storing that entire order as a single row makes this super efficient. This row-oriented layout is key to guaranteeing data integrity through something we call ACID compliance, which just ensures that every single transaction is processed safely and reliably.
Now let's jump over to the other side of this divide. If OLTP systems are the bookkeepers, then OLAP systems, and this is where ClickHouse absolutely shines, they're the data scientists. They couldn't care less about a single transaction. Their job is to analyze millions of them to uncover those big, strategic patterns.
OLAP, as you might guess, stands for Online Analytical Processing. These databases are engineered for one single purpose: to execute really complex queries against massive historical datasets and get you an answer back with extremely low latency.
So you can see right away, the priorities have done a complete 180. The goal now is blazing fast reading, not writing. I mean, look at that example query. What's the average order value across 10 countries over the last 3 years? To answer that, you might have to scan billions of rows. The only way to make that possible is to store data differently, in columns. All the order values are stored together, all the countries are stored together, and so on. This is what makes aggregations like sum and average unbelievably fast. This brings us to the single most important technical difference between these two worlds. How exactly does this difference in data storage work, and why on earth does it have such a massive impact on performance?
This slide pretty much says it all. On the left, you've got your row-based OLTP system. An entire record, name, email, balance, is all stored together as one continuous block on the disk. To access the balance, you literally have to read past the name and email first. Now look to the right. A column-based OLAP system stores all the values for a single column together. It is a fundamentally different physical layout. And this table just summarizes it perfectly. OLTP systems like Postgres, they handle current operational data with frequent updates. OLAP systems like ClickHouse, they're for massive historical archives where updates are pretty rare. And notice that last line, compression. We're going to come back to this, but that column-based layout allows for shockingly high data compression.
Okay, so we've established they store data differently, but let's get to the point. Why does this single architectural choice lead to such a dramatic, game-changing difference in speed for analytical queries?
The answer comes down to a physical bottleneck, disk I/O. Reading data from a physical disk is by far the slowest part of any database query. So if you want to calculate the average order value from a row-based system, it has to read every single row in its entirety. The customer name, shipping address, everything, just to get to the one number it needs, the price. It's incredibly wasteful.
How wasteful? Well, this is the magic of a columnar database like ClickHouse. Imagine you could just ignore almost all of that data you're forced to read. Because all the price data is stored together in its own block, ClickHouse goes directly to that block, reading only what it needs. It can physically bypass up to 99% of the data on the disk, which is precisely why these analytical queries feel instantaneous.
So, look, this isn't about one being better than the other. In the real world, you don't choose between them. A modern data architecture uses both for what they do best. A really common pattern looks just like this. Your live application runs on a transactional database like PostgreSQL, handling user accounts and orders. But every time an event happens, a copy is replicated over to your analytical database. That's where ClickHouse takes over, powering the dashboards that your business teams use to analyze trends and performance across millions or even billions of events.
And it all boils down to this core principle. Use the right tool for the right job. OLTP systems are for running the business, transaction by transaction. OLAP systems are for understanding the business, analyzing the entire data set at once.
Now that you understand this fundamental divide, we can dig deeper.
In the next chapter, we're going under the hood to see exactly how storing data in columns allows ClickHouse to achieve that incredible data compression we mentioned earlier. I'll see you there.
All right, let's dive right in. Everyone knows ClickHouse is fast, but why is it so fast? The answer relies in a really fundamental concept, something that's at the heart of high-performance analytics, columnar databases. Welcome back, everyone. This session is a key part of our ClickHouse Mastery Bundle from Durga Analytics. For those of you who've been with us from the start, you know the goal here. We're working through a massive 340-chapter curriculum. This isn't just about theory. It's about making you a master of ultra-fast OLAP analytics for real production-level environments. So let's get our bearings. We're currently in Module 1, which is all about getting the ClickHouse fundamentals down cold. And today we're on Chapter 3, where we're going to tackle the concept of columnar databases. Now, I can't stress this enough. This is the bedrock. Everything else we build in this course rests on this one idea. So let's really dig in. So here's the big question for today. What is the mechanical secret that makes ClickHouse just scream when it comes to analytics? I mean, we know it's an OLAP database, but what's really going on under the hood? It all boils down to a really, really crucial architectural choice, specifically how it physically puts data onto a disk. Okay, to really appreciate what makes ClickHouse so different, we first have to understand the old way of doing things. Let's talk about traditional row-based storage. This is probably what you're most familiar with, right? It's how most databases work, especially the ones built for transactional systems, your OLTP databases. Think about systems where you're constantly writing or updating one record at a time, like changing a user's profile or processing a single order. Let's use a super simple example to make this concrete, a sales log. You can see we've got 4 columns: the date of the sale, who the customer was, what product they bought, and of course, the price. So for that first line, we see that on March 1st, Alice bought a laptop for $1,200. Pretty straightforward, right? It's just a clean record of one transaction. Okay, now here's the most important part. In a traditional row-based system, this data gets written to the physical disk row by row. The entire first row is written, then the entire second row, and so on. You can think of it like this. Each row is a self-contained little package. All the info for that one sale, the date, the customer, the product, the price, it's all stored together, side by side, in one continuous block on the disk. And right here, this is where we hit a massive wall when it comes to analytics. Let's say your boss asks you, what were our total sales? Think about it. All you really care about is the price column, right? But to get that one number, a row-based database has no choice. It has to read the entire row from the disk. It has to load the date, the customer, and the product into memory just to get to the price. The analogy for this is just perfect. It's like having to read an entire book, cover to cover, just to find all the page numbers. It's an incredible waste of effort, and more importantly, disk I/O. So, how does ClickHouse completely sidestep this problem? Well, it takes a totally different approach. This is the big reveal. Column-based, or what we call columnar, storage. And trust me, this one simple shift in architecture is what makes all the difference in the world for analytics. The idea behind this is actually incredibly simple, but its effects are profound. Instead of storing data in rows, ClickHouse literally flips the table on its side. It physically stores each column in its own separate file. So you'll have one file that contains nothing but dates, another file with nothing but customer names, a third with products, and a fourth with prices. It's a totally different way of organizing the data on disk. Okay, now let's revisit that same question. What were our total sales? With this new kilometer structure, the whole game changes. The query becomes ridiculously efficient. ClickHouse knows it only needs the prices, so it goes directly to that single prices file. It reads only that file, sums up the numbers, and it's done. It completely, utterly ignores the files for dates, customers, and products. The amount of data it has to read from the disk is just a tiny fraction of what it was before. So this fundamental shift to columnar storage gives us two massive game-changing advantages, especially for analytics. First, it's blazing fast. And second, it takes up way less space on your disk. Let's break down exactly why that is. First up, let's talk about speed. The biggest bottleneck in almost any database query is reading data from the disk. I/O is slow, so by only reading the exact columns you need for a query, you are just massively cutting down on that I/O. That's the obvious win. But there's a second, more subtle advantage. It's way more friendly to your CPU. Think about it. When ClickHouse reads a column file, all the data is of the same type. It's all numbers or all strings. This means the CPU can load a big chunk of this uniform data into its super fast cache and then use special instructions to process many values at once. It's just incredibly efficient and lets the CPU fly through the calculations. All right, the second huge advantage is size. It turns out that columnar data isn't just faster to read, it's also way, way easier to compress. To really see why, let's imagine a classic analytics scenario. Let's say you have a country column in a giant table, and in that column, the word India appears, say, 200 million times. Now, in our row-based database, those 200 million Indias would be scattered all over the place, mixed in with other data. But in our columnar world, they're all sitting right next to each other, one after the other, in the country file. This makes a really clever compression trick possible, called run-length encoding. It's super simple. Instead of writing India, India, India 200 million times, the database just writes the value is India, and it repeats 200 million times. It stores the value once, and then the count. And the result? It's just a crazy reduction in storage space. It's not uncommon for techniques like this, which really only work well on columnar data, to achieve compression ratios of 90% or even more. We're talking about shrinking data down to a tenth of its original size. And think about what that means. It's not just about saving money on disks. Less data on the disk means less data to read for a query, which, you guessed it, means your queries run even faster. It's this awesome virtuous cycle. Okay, but here's a really important reality check. Columnar storage sounds amazing, and for analytics it is, but it is not a silver bullet. It's a specialized tool for a specific job. This whole design is a very intentional trade-off, one that is hyper-optimized for analytical performance, and that means it's not great for everything. So let's be clear about the good versus the bad. Columnar databases absolutely shine when you're aggregating huge amounts of data. Think running sums, averages, or counts across billions of rows. It's what they're built for. But where do they struggle? Fetching a single complete row. Think about a select star query for one customer. To do that, the database has to jump around on the disk. It has to go to the date file to get the date, then jump to the customer file for the name, then the product file, then the price file, and then it has to stitch all those little pieces back together. That's a lot of work compared to just grabbing one contiguous row. And that right there is the secret sauce. That's the mechanical secret to ClickHouse's incredible speed. You now understand the power of columnar storage, the one fundamental principle that makes these massive, real-time analytical queries even possible. So now that we have this core piece of the puzzle, in our next chapter, Chapter 4, we're going to zoom out. We'll look at the big picture, the entire ClickHouse architecture overview, and see how this idea of columnar storage fits into the whole system. I'll see you there.
All right, welcome back. I'm your instructor from Durga Analytics. So far, we've talked about what ClickHouse is. Now, we're going to peel back the layers and see how it all works. We're going to dive right into the architectural blueprint that gives it that insane speed for real-time analytics. Ready? Let's get started.
Okay, first things first, let's get our bearings. This is all part of the ClickHouse Mastery Bundle, a huge 340-chapter course designed to make you an absolute pro, ready for production environments. Right now, we're in the Foundation Core, specifically Chapter 4 of the Fundamentals module. This one's called ClickHouse Architecture Overview, and trust me, getting this down is super important for everything else we're going to cover.
So we all know ClickHouse is fast, right? Like ridiculously fast. But the big question is, how? What's the secret sauce? What's the magic going on under the hood? Well, that's exactly what we're going to unpack today. We'll look at the core design choices that make its speed not just a fluke, but something you can rely on even at massive scale.
All right, let's start small and look at what makes a single ClickHouse node tick. At its core, you've really got two main parts working together: the query processor and the storage engines. You can think of them as the brains and the brawn of the operation. And it's how these two work together that lets you get those crazy millisecond query times.
First up is the query processor. This is the brain I was talking about. It's the logical center of the whole server. Every single time you send a SQL query, it lands here first. Its main job? To figure out the smartest, most efficient way to get you your data, using as little computer power as possible.
And it does this with a pretty neat three-step process. First, it parses your SQL to make sure it understands what you're asking. Then it does the planning. This is where it figures out the absolute best game plan for running the query. And finally, execution. Now this is where a huge part of the magic happens. ClickHouse uses something called vectorized query processing. Instead of plodding along row by row like some other systems, it grabs whole chunks or vectors of data from a column and works on them all at once. This slashes the overhead and really lets modern CPUs fly.
So if the query processor is the brain calling the shots, then the storage engines are the super efficient workers on the factory floor. They handle all the physical stuff, how data is actually written to the disk, how it's compressed, indexed, and then pulled back up when a query needs it. This is where your data actually lives. One of the coolest things about ClickHouse is that it's not a one-size-fits-all system. It has what's called a pluggable architecture, which means you can use different storage engines for different jobs. The big one, the one you'll use 99% of the time for serious analytics, is the merge tree family. It's an absolute beast when it comes to indexing and sorting, but you've also got simpler log engines, maybe for temporary data, and even specialized engines that can talk directly to things like Kafka or S3. Super flexible.
Okay, so a single server is pretty powerful, for sure. But what happens when you're dealing with petabytes of data? You're going to need more horsepower. So in this next part, we're going to zoom out and see how ClickHouse goes from being one powerful server to a massive, coordinated cluster that can handle just about anything you throw at it. Now, when we talk about scaling out, there are two words you have to get straight in your head: sharding and replication. They sound similar, but they do totally different things, and it's so important to know the difference. Think of it this way. Sharding is for speed. It splits up your data and the work. Replication is for safety. It makes copies of your data so nothing gets lost. Performance versus reliability.
Let's make that real for a second. Imagine you have a massive table. If you shard it across 4 nodes, what happens? Well, instead of one server having to scan the whole thing, you now have 4 servers, each scanning just a quarter of the data, all at the same time. The result? Your query can be up to 4 times faster. It's a simple idea, but that's the raw power of scaling out horizontally.
Of course, when you have all these different nodes working together, you need a traffic cop to make sure they all stay in sync, right? In ClickHouse, that traffic cop is called ClickHouse Keeper. It's basically the central nervous system for the whole cluster. It keeps track of who's who, what the data structure is, and manages all the replication to make sure the entire system acts like one cohesive unit. It's based on an idea similar to Apache Zookeeper, if you're familiar with that. Okay, so we've seen the building blocks, the processor, the engines, and how they work together in a big cluster. Now let's get into the why. What are the deep-down design principles that make all of this speed possible? Here's a key concept: massively parallel processing, or MPP. ClickHouse was literally built to squeeze every last drop of power out of modern CPUs. So if you have a server with, say, 32 CPU cores, ClickHouse doesn't just use one of them. It can take a single complex query and break it down into 32 or more smaller tasks, that all run at the exact same time. It's all about using all the hardware you paid for to get answers back as fast as humanly possible.
But that MPP magic doesn't just happen on its own. It's built on a foundation of a few other really smart architectural decisions.
Yeah, there are really three core ideas that make this all work so well. First, you've got a shared nothing architecture. This just means every node is independent. It has its own brain, its own memory, its own storage. There are no bottlenecks, which lets you scale up smoothly. Second, data is stored in immutable parts. This is a big one. Once a chunk of data is written, it's never changed. This makes writing new data incredibly fast and avoids a ton of complexity. And finally, high availability is baked right in from the start using that replication we talked about. If a server goes down, no problem, the system keeps on running.
So, we've covered a lot of ground, from the guts of a single server to how a whole cluster works. Let's just pull it all together and summarize the key takeaways.
When it comes right down to it, the insane speed of ClickHouse isn't because of one single trick. It's the combination of three powerful ideas working together. First, columnar storage, which we covered back in Chapter 3. It means you only read the data you actually need. Second, massive parallelism, using every CPU core to attack a single query. And third, a distributed design that lets you scale out across tons of servers with shards and replicas. It's that trio, columns, parallelism, and distribution, that creates the magic.
All right. So now you have the blueprint. You understand the theory behind why ClickHouse is so fast. The theory is officially over. It's time to stop talking and start doing. Let's get our hands dirty.
In the very next chapter, Chapter 5, we're going to do just that. I'm going to walk you step by step through installing ClickHouse right on your own machine. By the end of it, you'll be able to start running queries and putting all this theory into practice. It's going to be a lot of fun. I'll see you there.
Welcome back to the Durga Analytics ClickHouse Mastery course. We are on an epic 340-chapter journey to build truly production-grade data warehouses. Today is a big day. We're moving from theory to practice and taking on one of the most important steps in this whole course, installing the ClickHouse server itself. So just to get our bearings, we're still in Module 1, building up those core fundamentals. This is Chapter 5. All that theory we've covered about architecture and columnar storage, well, right now, we're about to make it real by setting up our very own development environment. So, this chapter is all about getting ClickHouse installed. And I want you to think of this as more than just a tech exercise. This is the foundation. Everything we do from here on out, from simple data pipelines to massive complex clusters, is going to be built right on top of what we do today. And here's the really cool part. You can get a full production-capable ClickHouse server up and running in under 2 minutes. Yeah, you heard that right. It's a perfect example of just how lightweight and efficient this system is. All right, let's dive in. Okay, first things first. Before we type a single command, we need to get our environment ready. This is a super important step because your choice of operating system and how you install it will affect not just the setup, but your long-term stability and performance. So what you see here are your main options. In the real world, for production systems, a native Linux installation is the gold standard. You're going to get the best performance that way. For development, if you're on Linux or Mac OS, native is still a great choice. But for all you Windows users, the best practice is to use either Docker or WSL2. This keeps everything clean, isolated, and ensures your dev environment acts just like a production one would. Now, for the most straightforward and repeatable setup, especially when you're just getting started, we're going to go with Docker. It's fantastic because it creates this nice little bubble for ClickHouse to live in, completely separate from your main operating system. It just guarantees things will work the same way every time. The whole process with Docker really just boils down to 2 main commands. First, we're going to pull or download the official ClickHouse server image. And second, we're going to run that image as a container, which is what actually fires up the database server. And here are those exact commands. You'll want to pause here and run these directly in your terminal. The Docker run command has a few parts. The D flag runs it in the background. Dash name gives our container a handy name. And then, most importantly, we map the ports from inside the container to our own machine so we can talk to it. So let's quickly break down those port numbers you just saw because they're pretty important. Port 8123 is the one you'll use for things like web interfaces or connecting through HTTP. But port 9000, that's the one we really care about right now. It's the native connection port, and it's how we'll be interacting with the database for the next several chapters. Now, what if you're not using Docker? Totally fine. If you're on a Linux server or a Mac and you want to install it directly, that is a perfectly valid production-grade way to go. So let's take a quick look at how that works. So if you're on a Debian-based system like Ubuntu, it's a pretty standard three-step dance. First, you tell your system where to find the official ClickHouse packages. Second, you use your package manager to install the server and the client. And finally, you just start it up as a system service. And here they are. This is the command sequence for that native Linux install. Again, this is for those of you who prefer a setup directly on the machine. It's a bit more hands-on than Docker, for sure, but it gives you that direct control. And hey, if you're on a Mac, you've got it the easiest. Seriously, if you have Homebrew installed, it's just one simple command. Brew install ClickHouse. That's it. It does all the heavy lifting for you. Okay, so no matter which path you took, Docker, Linux, or Mac, your server should be up and running right now. So now for the moment of truth. Let's see if it's alive. Go ahead and open up a fresh terminal window. We're going to connect to the server using the native client. All you have to do is type ClickHouse client and hit enter. This will automatically try to connect to your local server on port 9000. So, what do you see on your screen? If everything went to plan, you should see a new prompt has appeared. And there it is, a simple smiley face. That's the official ClickHouse command line prompt. It's a friendly little confirmation that your server is up, running, and ready for your commands. So congratulations, you officially have a working ClickHouse instance. For one last definitive check, let's run our very first query. Just type select version and press enter. The server should talk back to you and tell you its version number. This confirms everything is working perfectly. Now, of course, things don't always go perfectly on the first try. So if you didn't get that smiley face, don't worry at all. Let's walk through a few of the most common hiccups and how to fix them really quickly. Okay, 3 common things to look out for. First, if you're on Linux and see a permission denied error, you probably just need to run the command with sudo. Second, if you can't connect, it might be a port conflict. Some other program might be using port 9000. And finally, if you see memory warnings on a machine with not a lot of RAM, that's normal. ClickHouse loves memory, but for learning, it'll work just fine. All right, you've done it. You have a live ClickHouse server at your fingertips, which is a huge milestone. You've got the engine, and now it's time to learn how to drive it like a pro. And that sets us up perfectly for our next chapter, Chapter 6, Mastering Server and Client Tools. Now that our server is running, we're going to dive deep into the command line, explore all the essential tools, and get you comfortable with everything you need for day-to-day operations. I'll see you there.
All right, welcome back everyone to the ClickHouse Mastery course from Durga Analytics. In this chapter, we're going to get our hands dirty with the essential server and client tools. This is your command center. This is how you talk to ClickHouse. So let's dive right in.
So, just to quickly get our bearings, we're still deep in Module 1, the fundamentals, of our huge 340-chapter curriculum. We've just gotten to installation, which brings us right here to Chapter 6, the server and client tools. Honestly, these are the tools you're going to be using every single day to manage your data, so this is a big one.
And this leads us to the most important question right now, doesn't it? You went through all the trouble of getting this incredibly powerful database installed and running, but now what? How do you actually talk to it? How do we send it commands, load our data, and see the results? Well, today, we're going to master the tools that let us do just that.
turning ClickHouse from just a running process into an engine we can truly command.
Okay, our first stop has to be the heart of the entire operation, the ClickHouse server. This is the component that does all the real work, the heavy lifting, and it just hums along quietly in the background.
I absolutely love this analogy. Think of ClickHouse Server as the engine of a high-performance car. You don't get in your car and start messing with the pistons directly, right? You just trust that the engine is on, it's running, and it's ready to go. That's exactly what the server is. It's a system service that's always on, managing storage, handling memory, and just waiting for your instructions.
Now, how do you tune this engine? You do it through its configuration files, which you'll typically find in the /etc/clickhouse-server/directory. The two you absolutely have to know are config.xml, that's for system-wide stuff like network ports and memory limits, and users.xml. This one is all about security. It's where you'll set up user permissions and, critically, resource quotas to stop a bad query from taking down your whole production system.
Okay, so if the server is the engine, how do we actually drive this thing? Well, it's time to get in the driver's seat. The ClickHouse client is your dashboard, it's your steering wheel, it's all your controls. This is how you tell the engine what to do.
For any of us working as data engineers, developers, or database admins, the native ClickHouse client is going to be your absolute best friend. It's a no-nonsense command line tool built for one thing: raw speed. It gives you the most direct, lowest latency connection possible to the server. This is where you'll be spending most of your time.
Now, the client is really cool because it kind of has two different personalities. First, you've got interactive mode. This is your playground. You just type ClickHouse client, you get that little smiley face prompt, and you can start writing and testing queries live. But then there's batch mode. This is the workhorse. This mode is all about automation and loading massive amounts of data by streaming it directly into the database. And I really want this to sink in. Batch mode isn't just a neat trick, it's a professional-grade power move. This is exactly how you'll ingest huge data sets in a production environment with maximum efficiency. Think about it. You can often bypass writing any complex application code altogether. So let's look at the syntax. It looks a little intimidating, but it's incredibly elegant. The cat data.csv part just reads the contents of a file, then you see that vertical bar, the pipe symbol. Think of that as a tube that connects the output of the first command directly to the input of the next one. So we're piping our CSV data right into the ClickHouse client, which is running an insert query. And the crucial part is telling it the format is CSV. It's a beautiful high-speed data pipeline right in your terminal. Okay, look, the command line is amazing, but let's be realistic. It's not always the right tool for every task, and it's certainly not for everyone on the team. Sometimes you just need a good old-fashioned dashboard. So let's look at some more visual, user-friendly ways to interact with our ClickHouse engine. One of the coolest things that comes right out of the box is a simple built-in web interface. Seriously, it's this easy. You open a browser, go to your server on port 8123, and add /play to the end of the URL. What you get is a clean Scratchpad environment where you can run queries and see the results instantly. It's perfect for quick ad hoc analysis when you don't want to install a full client.
Now, when you're ready for something with a bit more horsepower, you're probably reached for a third-party tool. dbeaver is like the Swiss Army knife for databases. It works with everything, including ClickHouse. Tabix is a great open-source choice that's built specifically for ClickHouse. And then you have Grafana. Now, Grafana is a bit different. You don't use it to write queries, you use it to build powerful, beautiful dashboards to visualize and monitor all the amazing data you're storing in ClickHouse.
All right, before we wrap up, I want to give you a little survival kit for the command line. Think of these as the essential commands that you're going to be using constantly inside the ClickHouse client.
The first two are your navigation tools, show databases and show tables. That's how you look around and see where you are. Now the third one, select *from system.processes. This one is your lifesaver. When a query is running slow and you don't know why, this command shows you exactly what's happening. And finally, the big red button, Control+C. This is your emergency brake. It instantly kills whatever query is running without kicking you out of the client. Master these 4, and you're well on your way.
So if you only remember one thing from this entire chapter, make it this. The server does the work and the client tells it what to do. It's that simple. The server is the muscle and the client, whether it's the command line or a fancy GUI, is the brain giving the orders.
So this leaves us with a pretty big question. You now know how to drive. You have the engine and you have the controls. The real question is, what are you going to build? Because before you can build anything robust, you have to deeply understand your raw materials. And in the world of databases, your most fundamental building blocks are the data types. That's exactly what we're going to master in our next chapter, Chapter 7. Choosing the right data types is absolutely critical for performance and storage, so you are not going to want to miss this one. I'll see you there.
Hey everyone, and welcome back. I'm your instructor from Durga Analytics, and we're jumping right back into our ClickHouse Mastery course, where our goal is to get you building production-level, incredibly fast data warehouses. Just to quickly remind you where we are, this is all part of our massive 340-chapter curriculum. You know, the goal here is way beyond just learning a few queries. We're here to give you the skills you need to architect and manage enormous real-time analytics systems. And what we're talking about today, well, it's an absolute cornerstone of that entire skill set. So we're in Module 1, still laying down those critical fundamentals. This is Chapter 7, and we're talking about ClickHouse data types. Now, I know what you might be thinking. Data types? That sounds pretty basic. But let me tell you, in the world of ClickHouse, getting this right isn't just some best practice. It's the secret to unlocking absolutely mind-blowing performance. So here's the game plan for today. First, we're going to talk about why data types are so critical in a columnar database. Then we'll open up the toolbox and we'll look at the standard types and the more advanced power tools you have. I'm also going to show you a really common but super costly performance trap to avoid. And then, of course, we'll wrap it all up. All right, let's get right into it. You might be thinking, a whole chapter on data types? Really? Isn't that a little 101? And you know, in a traditional row-based database, maybe you'd have a point. But here, in a columnar system like ClickHouse, your choice of data type is honestly one of the biggest performance decisions you can possibly make. This quote really nails it. Let me give you an analogy. A traditional database is kind of like a library, where every book's info, title, author, page count, is all on one big index card. If you want to find all the authors, you have to scan through every single card. But ClickHouse, it's different. It's like having separate, highly optimized lists. One list of just titles, another of just authors. When you pick a data type, you're deciding how that entire list gets built and compressed. Get it right, and suddenly, everything just flies. And I mean, the difference is truly night and day. If you pick some massive data type for a tiny piece of information, you're not just wasting disk space. You're making the CPU read and process way more data than it needs to. But when you pick that perfect, tight data type, you enable this amazing compression and you unlock those lightning-fast queries that make ClickHouse an absolute analytics beast. So with that in mind, let's go ahead and open up the Architect's Toolkit. We'll kick things off with the fundamental data types. These are going to be the bread and butter of pretty much every table you ever design. For any column that holds a number, this has to be the very first question that pops into your head. It is so easy, so tempting to just default to a big int64 and just call it a day, right? But every single time you do that, you're letting a little bit of performance just bleed away. In ClickHouse, being precise means being efficient. Let's make this real. 7 bytes. I know, it doesn't sound like much, does it? But that is what you save on every single row just by using a tiny int8 for something like a person's age, instead of the default int64. Now, scale that up to a billion row table. You've just saved 7 gigabytes of disk space and, more importantly, 7 gigabytes of memory that doesn't have to be read during a query. That's not a tiny optimization. That's a genuine game changer. Okay, so in your standard toolkit, you've got things like uint32 for positive integers, perfect for user IDs, things that are never going to be negative. You've got float64 for scientific data where maybe absolute precision isn't the #1 priority. And this one is non-negotiable. If your data involves money, you have to use decimal. Using a float for financial data can create these tiny little rounding errors that can become huge problems down the line. Trust me, that is not a conversation you ever want to have. Now, when it comes to text, the choice is usually pretty straightforward. If the length can change, like a user comment or a log message, you're going to use string. Simple. But if you know for a fact that the text will always be a certain length, like a 3-letter currency code, use fixed string. This is a great little optimization because it tells ClickHouse, hey, you can skip checking the length of every single value in this column, which gives you a small but very real performance bump across millions of rows. Here's a really clever thing that ClickHouse does behind the scenes. When you store a date, ClickHouse isn't actually seeing January 1st, 2024. No, it sees a number, basically the number of days or seconds since a specific point in time. And what that means is, when you ask it to do date plus 7 days, the CPU is just doing super fast, simple integer math. It's incredibly efficient, and it's a huge reason why date-based analytics are just so fast in ClickHouse. Okay, we've got the basics down. Now, let's get to the really powerful stuff. These are the specialized data types that let you solve complex analytics problems in ways that would be super slow or just plain awkward in a traditional database. First up is the array, and this is a total game changer. It lets you store a whole list of items right inside a single row. So picture a blog post with a bunch of tags. Instead of having a separate tags table and doing a really expensive join every single time, you can just store an array of the tag IDs right there with the blog post. Avoiding that join is a massive, massive performance win. And next up is the map type. You can think of this like having a tiny little key value database tucked inside a single cell. This is amazing for semi-structured data where the attributes aren't always the same. Like, imagine you're tracking events. One event might have a user ID and page, but the next one has an item ID and a price. A map lets you handle all that flexibility without having to add dozens and dozens of columns to your table. It's fantastic. The enum type. This is one of my personal favorite optimizations. It's designed for columns that have a small, fixed set of values, like status columns, pending, success, failed. What happens is, behind the scenes, ClickHouse stores a super efficient little number, but when you query the data, it shows you the human-readable text. So you get the performance of an integer with the readability of a string. It's truly the best of both worlds. Okay, so we've seen all the cool power tools. Now it's time for a word of warning. We need to talk about a really common trap that a lot of developers fall into. It's a feature that looks totally harmless, but it can quietly kill your query performance if you're not paying attention. You know, a question I get all the time, especially from people coming from systems like Postgres or SQL Server, is, what about missing data? Can I just use nulls? And look, the short answer is yes, you can. But in ClickHouse, that yes comes with a huge flashing neon asterisk next to it that says performance warning. So here's the critical thing you have to understand. When you make a column nullable, ClickHouse has to create a whole separate file on disk called a null map, just to keep track of which rows have a value and which ones are null. So now, every time you query that column, ClickHouse has to read from 2 files instead of just 1. That extra disk I/O, it adds up, and it slows you down. The pro move always is to avoid nullable if you can, and just use a sensible default value instead, like a 0 for numbers or an empty string for text. Whew, all right, that was a lot to get through, but it's all so important for building fast, efficient tables. Let's just do a quick recap of the key data types we've added to our toolkit before we look at what's coming up next. Think of this table as your go-to cheat sheet when you start designing your own tables. It maps out the common kinds of data to their best fit high-performance ClickHouse type. For IDs, you're thinking uint32. For event timestamps, datetime. For lists of things, array. And for really specialized stuff like web traffic, you even have purpose-built types like IPv4. If you use this as your guide, you're going to be on the path to high-performance design right from the very beginning. So we've now really mastered the fundamental building blocks of any table in ClickHouse, right? We have our raw materials, the data types. The obvious next question is, how do we actually use these tools to start building something? And that is exactly what we are going to tackle in Chapter 8. We're going to take this entire toolkit and use it to construct our very first databases and tables. We'll also introduce another absolutely critical concept, table engines. It's going to be a fantastic session, and I can't wait to see you there. Welcome back to another deep dive from Durga Analytics. In this session, we are tackling an absolutely critical skill for anyone building a real production-level data warehouse, creating databases and tables in ClickHouse. And we're going to go way beyond just the basic commands, because we need to understand how these initial steps are the foundation for the incredible performance ClickHouse is famous for. So, just to get our bearings, we are right here in Chapter 8 of our massive 340-chapter ClickHouse Mastery Bundle. We're still building up that ClickHouse Fundamentals module, laying the solid groundwork that's going to support everything we do later on. All right, let's get into it. Here's what's on the menu for today. We'll kick things off with the simple act of creating a database, but we're going to quickly pivot to the real heart of the matter, how to design high-performance tables. This, right here, is where we start to unlock the magic of ClickHouse. In our last chapter, we spent some time on the building blocks, all those different data types. Now it's time to actually use those blocks to build something. We're going to construct the containers for our data. This is really where the theory hits the road. Okay, this is a huge concept. You've got to get this in your head right now. In a lot of databases, a table is just a passive bucket for your data. But in ClickHouse, no way. The create table statement is an active declaration of your performance strategy. You are literally telling ClickHouse how you plan to query the data so it can optimize the heck out of the storage. All right, let's dive in with the very first, most basic step you'll always take, creating a dedicated space for our tables to live. Don't overthink this part. A database in ClickHouse is really just a logical container. The best analogy? It's exactly like creating a new folder on your computer for a specific project. It's all about keeping things organized. Simple as that. And the syntax is just as simple. The command is super straightforward, and using if not exists is just good practice. It's a little safety net that makes sure your command runs without any errors, even if you accidentally run it twice and the database is already there. All right, so our folder is created. Now we can get to the main event, drafting the architectural blueprint for our data. And that blueprint is the create table statement. Now, take a look at this. This is what a complete production-ready sales table looks like. I know it might seem like a lot's going on at first glance, but don't worry. We're going to break this down into its 3 essential components right now. So every single create table statement you write in ClickHouse is built on these 3, let's call them non-negotiable pillars. You have the schema. That defines what your data is. Then you have the engine and the order key. Together, these 2 define how your data is stored and optimized for mind-blowing speed. And while the schema is obviously important, it's your choice of engine and order key that really turns a simple table into a high-performance analytics machine. This is where you design for speed. It's a game changer. Just look at the difference here. Sure, you might use a log engine for a quick test or something trivial, but for anything serious, any production-grade table, you are going to use an engine from the merge tree family, period. Why? Because merge tree engines give you the good stuff. Indexing, partitioning, and that background data merging that's so essential for high performance at scale. So here's the golden rule, the crucial point. Your most common query patterns must drive your table's physical design. Think about your where clauses. What are you always filtering by? A date range? A specific customer ID? Whatever those columns are, they need to be front and center in your order by clause. And this slide explains the magic behind why that order by clause is so powerful. It creates something called a sparse index. Think of it like a hyper-efficient table of contents for your data. So instead of reading the entire book, all your terabytes of data on disk, ClickHouse just looks at this table of contents and can jump directly to the relevant chapter, skipping over huge, irrelevant blocks of data. That's how it scans billions of rows in milliseconds. It's brilliant. Okay, let's see how all this theory translates into the practical, day-to-day work of managing your tables. ClickHouse has some incredibly efficient, time-saving commands that you're going to love. So let's say you need a quick backup or maybe a staging table for an experiment. You can instantly clone an entire table, the schema, the engine, the order key, all the data with this one simple command. It is so useful. This is another one of those famous ClickHouse features. You can just point it at a file, like a CSV, and it will not only create the table for you, but it'll also figure out the schema and load all the data. It just makes ad hoc analysis and getting data in remarkably efficient. And here they are, the 3 commands you'll probably use every single day. Describe to take a peek at your structure, truncate to quickly wipe out all the data but keep the table itself, and of course, drop to completely nuke the table and all its data for good. Okay, let's bring it all home and wrap this chapter up by hammering home the single most important idea you should walk away with today. Please, if you remember one thing, remember this. Every single time you type create table, you are actively tuning for performance. Your choices for the engine and the order by key aren't just passive definitions. They are the very foundation of your query speed. So, we've done it. We've designed the perfect blueprint for our house, right? But we haven't seen the raw materials yet. What do those bricks and mortar actually look like on the hard drive? Well, that's exactly what we're going to explore in Chapter 9, where we dive deep into column storage fundamentals. We're going to see what's physically happening on your disk. I'll see you there. Welcome! We're diving deep into the ClickHouse Mastery course from Durga Analytics. Today, we're going to uncover one of the biggest secrets behind ClickHouse's mind-blowing speed. It's column storage architecture. You know, to really get those ultra-fast analytics, you've got to understand what's happening under the hood. And that's exactly what we're breaking down today. All right, before we jump in, let's just get our bearings. We're right in the middle of Module 1, which is all about ClickHouse fundamentals. And our focus for this session is Chapter 9, a really critical piece of the puzzle: how ClickHouse actually stores your data on disk. So, let's start with what seems like a really simple question, but one that has a surprisingly powerful answer. You run a basic insert statement. Data goes into the database. Easy, right? Well, what really happens behind the scenes? To understand why ClickHouse is just so fast, we need to follow the journey of that data from the moment you hit enter all the way down to the physical disk. Okay, let's get into the blueprint. The entire storage model for merge tree tables anyway starts with this simple but pretty radical rule. ClickHouse creates a separate dedicated file for every single column in your table. Yep, you heard that right. If your table has 50 columns, you're going to have 50 different data files on your disk. This is the absolute cornerstone of its design. And for each of those columns, ClickHouse creates 2 essential types of files. You can think of it like a super organized file cabinet. The first type, the .bin file, holds the actual raw compressed column data. This is the meat, the content of your folders. And the second type, the .mrk file, acts like a set of bookmarks or index tabs, telling ClickHouse exactly where to find things.
So how do these two files, the data and the bookmarks, work together to deliver that legendary ClickHouse speed? Well, the whole system is designed to be smart by being, well, a little lazy. It's all about avoiding reading any data that isn't absolutely necessary for your query. And the magic behind this is a concept called a granule.
Now, unlike traditional row-based databases that might read data one little record at a time, ClickHouse doesn't really think in terms of individual rows when it's reading from the disk. It thinks in granules. And a granule is simply the smallest chunk, the smallest block of column values that ClickHouse will ever read from the disk in one go. And that fundamental unit, that chunk, has a standard size. By default, a single granule contains the data for 8,192 rows for any given column. So when ClickHouse goes to the disk, it's not asking for a single value. It's asking for a block of 8,192 values at a time. This batching makes every single read operation incredibly efficient. And this is where those .mrk files, our bookmarks, come into play and become so important. Each mark in that file is basically a pointer. It's an address that says, hey, granule number 5 for the user ID column, it starts at this exact byte offset in the big.bin data file. This lets ClickHouse jump directly to the granules it needs and completely ignore, literally skip over, potentially terabytes of other data that don't match your query. It's brilliant.
Let's talk about the navigational tool for this whole system. If granules are the paragraphs and the marks are the page numbers, then the sparse index is the table of contents. And it is a radically different approach compared to what you might be used to in other database systems. And this slide just illustrates the difference perfectly. A traditional B-tree index, it has to point to every single row. This can make the index itself massive, and it's slow to search because it lives on disk. The ClickHouse sparse index, on the other hand, is genius in its simplicity. It only stores the primary key value for the start of each 8,192 row granule. This makes the index incredibly small. So small, in fact, that it lives entirely in RAM, making lookups almost instantaneous. Okay, so we've talked a lot about reading, but let's switch gears and look at the write path. What happens when you actually write data? Well, the process is designed for maximum speed, and it revolves around this concept of immutable data parts. Every single time you run an insert statement, ClickHouse creates a new self-contained little directory on the disk called a data part. This part has all the .bin files, all the .mrk files, everything needed for that specific batch of data. And here's the crucial bit. Once that part is written, it is never, ever modified. It's immutable. This totally eliminates complex locking mechanisms and makes writes blazing fast. Now, you might be thinking, hold on, doesn't this create a ton of small files? And you'd be absolutely right, it does. But ClickHouse has a really clever solution for this. As you keep inserting data, new little parts are created. But in the background, a completely separate process is always running, looking for small, similar parts and merging them together into new, larger, more optimized parts, sorting the data as it goes.
So why do we care about all these details? Well, the crucial point is that understanding this architecture isn't just some academic exercise. Knowing how ClickHouse stores and manages data on the disk is the absolute key to unlocking its full performance. It directly tells you how you should be designing your tables and your data pipelines. And this all leaves us with two very clear, actionable rules for building a high-performance system. Number one, always insert your data in large batches. Think 10,000 rows or more as a good starting point. This prevents creating tons of tiny parts and reduces the work the background merge process has to do. And number two, choose your table's order by key very, very carefully. This is your primary key, and the more selective it is, the more granules your queries can skip, which leads to massive performance gains. You know, when you take a step back, every single feature we've talked about, the column files, the 8,192 row granules, that in-memory sparse index, the background merging, it's all designed to do one simple thing: to minimize the amount of work and the physical distance the system has to travel to find the exact data your query needs on that disk. So having this foundational knowledge of the storage layer is absolutely critical. But of course, storing data is only half the battle. In our next explainer, we're going to build directly on what we learned today as we move into Chapter 10 and explore how to pull this data back out efficiently using basic SQL queries. We'll be running our first real analytics commands. See you there.
Hey everyone, and welcome back. I'm with Durga Analytics, and we are diving right back into our ClickHouse Mastery Bundle. This is the whole shebang, our 340-chapter curriculum designed from the ground up to get you building production-grade, unbelievably fast data warehouses. Today we're hitting a really critical topic: basic SQL queries.
So just to get our bearings, we are right in the middle of Module 1, ClickHouse Fundamentals, and we've landed on Chapter 10. We spent the last few chapters getting our environment all set up, so now it's time for the fun part: actually talking to our data and pulling out its value using the universal language of analytics, good old SQL.
All right, so here's the game plan for this chapter. We're going to start with the absolute workhorse of any query, the select statement. Then, and this is huge, we're going to cover the single most important thing for getting speed out of ClickHouse: filtering. After that, we'll look at some basic aggregations, sort out the difference between limit and sample, which is super important, and then wrap up with a cool feature for formatting your output.
First up, the most fundamental command in pretty much all of SQL, the select statement. But here's the thing. In ClickHouse, you kind of have to think about it a little differently than you might be used to with traditional databases.
If you only remember one thing from this entire chapter, please let it be this. In ClickHouse, you have got to be specific. And this isn't just some nice-to-have clean code best practice. No, this is the absolute core principle for performance. So why is that? Well, it all goes back to ClickHouse's columnar architecture, where every single column is stored in its own separate set of files on disk.
Let's look at the physical reality of what's happening on this slide. On the left, when you do select star, you're telling ClickHouse, hey, go find and open every single file for every single column in this table. It's just a brute force attack. But the best practice on the right, that's surgical. It only touches the two files it absolutely needs, which makes it orders of magnitude faster.
And building on that, you don't have to just select raw data. You can actually do your calculations right there in the query. ClickHouse is literally built for this. It uses something called vectorized execution. The easiest way to think about it is like a CPU assembly line. Instead of processing one little piece of data at a time, it grabs huge batches, or vectors, and processes them all at once. The speed is just incredible.
This query right here is a perfect example. We're calculating an 18% tax, and we're giving it a name, an alias, called tax_amount. Now, the really powerful part is that ClickHouse lets us immediately use that new tax_amount alias in the very next calculation to get the total price, all in one go. It just makes writing complex business logic so much cleaner.
Okay, so we know how to select the right columns. Now let's talk about selecting the right rows. The where clause is, without a doubt, your most powerful weapon for making queries ridiculously fast. To really unlock what the where clause can do, you first have to get your head around the sorting key. See, in ClickHouse, that order by you define when you create a table, that's not just for making the output look nice. It actually dictates the physical order of the data on the disk. This lets ClickHouse use its special sparse index. Think of it like this. It's not an index of every single page in a book, but just the first page of every chapter. It lets ClickHouse know where massive chunks of data begin and end.
So here's the million-dollar takeaway. When your where clause filters on a column that is part of that sorting key, ClickHouse doesn't have to read every row. It uses that sparse index to instantly jump over these massive blocks of data that it knows it doesn't need.
It's the difference between reading a whole textbook from cover to cover versus just using the index to find the exact page you're looking for.
So for example, if order date is the first column in your sorting key, this query is it's blazing fast. ClickHouse looks at its index, figures out exactly where the data blocks from March 1st, 2026 are, and it completely ignores everything else on the disk.
All right, let's get to the real heart and soul of any analytical workload, aggregations. I mean, this is what OLAP systems like ClickHouse were literally born to do.
Functions like count, sum, and average, these are the bread and butter of analytics. And because ClickHouse stores data in columns, it can just stream these columns of numbers directly into the CPU to do the math. It can chew through millions, even billions of rows in the blink of an eye.
Now let's tackle a topic that, trips people up all the time. Both limit and sample will reduce the number of rows you get back, but they are totally different tools that you use for completely different jobs. Okay, getting this slide is absolutely key. Limit basically lets the entire query run, does all the work, and then at the very end, it just gives you the first few rows of the final result. It's for when you want to preview a complete, accurate answer. Sample, on the other hand, tells ClickHouse to only run the query on a fraction of the total data to begin with. It's incredibly fast and perfect when you just need a rough, back-of-the-napkin answer for trend analysis on huge data sets.
And lastly, let's talk about a really convenient feature that's super helpful for data engineers and analysts. You don't have to rely on your client tool to format your results. You can actually tell ClickHouse exactly what format you want the data in right in the query.
This is just so useful. If you're building an API, you just tack on Format JSON to the end of your query, and boom, you get a perfect JSON object back. No fuss. And if you're in the command line client trying to read a table that has, 50 columns, Format Vertical will pivot the whole thing so you can actually read it without your head spinning. Okay, I know that was a lot, but these really are the foundational commands. So let's just do a quick recap of the core building blocks we've covered. Think of this slide as your cheat sheet. We've learned projection, that's how we pick our columns, filtering with where, that's how we pick our rows, renaming with AS to make things clear, the basic aggregations, and of course, sampling for when you need a quick look. These are the tools you're going to be using every single day. And that really brings us to the end of Chapter 10. We've got the basic tools down now. We can select, we can filter, we can aggregate. But that leads to the big question, right? The real secret to making these queries absolutely fly, as we've hinted, isn't just about the query, it's about mastering the physical order of the data. And that question sets us up perfectly for what's coming next. In our next session, Chapter 11, we are going to answer that exact question. We're going to build directly on everything we just learned and do a deep dive into the order by key, really unlocking the full performance potential of that sparse index. We'll see how mastering data order can make your analytics feel truly instantaneous. I'll see you there.
Welcome, everyone. I'm with Durga Analytics, and in this chapter of our ClickHouse Mastery course, we're diving into something that's absolutely fundamental for building production-level data warehouses: how to filter and sort your data the right way. Honestly, mastering this is the real key to getting that insane sub-second query performance that ClickHouse is famous for.
So, just to quickly get our bearings, in our big 340-chapter curriculum, we're right here in Chapter 11. We're still building up that solid base in the ClickHouse Fundamentals module. What we're covering today is crucial because it sets the stage perfectly for our next chapter on aggregation basics. Here's our game plan for this session. We're going to start with the why filtering is just so important. Then we'll get hands-on with the where clause and some really cool advanced operators. After that, we'll talk about sorting data intelligently, and we'll wrap up with a powerful ClickHouse-only feature called the pre-where optimization. Okay, let's dive right in with the most important idea. When you're working in a real production system, how you filter and sort isn't just a minor detail, it is the number one thing that's going to determine your query performance. This is what makes the difference between a query that finishes in 10 milliseconds versus one that takes a full 10 seconds.
And I'm not exaggerating here. That performance gap is massive. With a database like ClickHouse that's built for speed, your filtering strategy directly decides if your query feels instantaneous or painfully slow. And the reason for this comes down to something really fundamental. It's all tied to how the data is physically laid out on the disk.
So your main tool for this, your go-to workhorse, is the where clause. Its whole job is to tell ClickHouse what data to completely ignore. We call this data skipping, and it's a core concept that makes all high-performance analytics possible in these columnar systems.
The best way to think about this is with a library analogy. Using an index is like using the library's catalog to find the exact shelf a book is on. It's super targeted, super efficient. A full column scan, on the other hand, is like walking down an entire aisle. It's not as direct, but it's still surprisingly fast in ClickHouse because it only has to read that one single column it needs, ignoring everything else.
So, take a look at this example. If your table's primary key is based on order date, this query is going to be incredibly fast. ClickHouse uses its index to just jump straight to the data blocks for March 1st, 2026, and it skips reading pretty much everything else.
But what if customer name is not in your primary key? Well, in that case, ClickHouse has to do a full scan of that customer name column to find all the rows for Alice. It's not as fast as the index seek, for sure, but it's still way, way faster than a traditional row-based database that would have to read whole rows of data off the disk.
All right, so we've got the basics down. Now, let's expand our filtering toolkit a bit. ClickHouse gives us some really specialized operators that are designed to handle more complex situations, and they do it with incredible performance. You should know that these operators are seriously optimized. The in clause, for example, stays fast even if you give it a list of thousands of values. And here's a big one. Multi-search any should be your go-to instead of chaining a bunch of like conditions with or. It gives you a huge performance boost. So you can and you should use these with confidence in your queries. Okay, let's switch gears and talk about sorting. In ClickHouse, the order by clause kind of has a dual personality, and it is absolutely critical to understand the difference between sorting for storage versus sorting for your results. So that first type, the one you define when you create the table, that's what dictates your query speed. It's what makes that fast index seek possible. The second type, the one you use in your select query, just arranges the final data you see. So one is all about performance and the other is all about presentation. Now here's a pro tip you absolutely need to remember. When you combine order by with limit, ClickHouse does something really smart. It uses what's called a top-n algorithm. So instead of sorting billions of rows, it just keeps track of the top-n results in memory as it goes. This saves a massive amount of CPU and memory. And now, let's talk about one of ClickHouse's most powerful, most unique features for optimizing I/O. This is the secret weapon, the pre-where clause. Understanding this is a total game changer for certain kinds of queries.
So what pre-where does is it introduces this really efficient two-stage filtering process. First, ClickHouse only reads the columns needed for the pre-where condition to do a quick, lightweight filter. Then, and only for the rows that pass that first check, it goes back and reads the other columns you selected in your query.
This is a perfect example. ClickHouse will first scan only the city column, which might be really small and easy to read. It finds all the rows for Mumbai. Then, just for that much smaller set of rows, it'll read customer name, address, and age to apply the final where condition. It just dramatically cuts down the amount of data it has to read from the disk. So let's just boil this all down into a quick summary of what we've learned. Number 1, always try to filter on your primary key columns for the biggest speed boost. Number 2, use pre-where when you can apply a very selective filter on a lightweight column to minimize I/O. And number 3, always pair order by with limit if you just need the top or bottom results. It's a huge resource saver.
So we've gotten really good at finding the exact data we need and organizing it efficiently.
What's the next logical step? Well, it's actually doing some calculations on it. We figured out how to isolate the data. Now it's time to learn how to analyze it.
And in our next chapter, that's exactly what we're going to explore. We'll dive into the fundamentals of aggregation, looking at functions like count, sum, and average. We'll see how ClickHouse's architecture lets it perform these calculations at unbelievable speeds. Thanks so much for joining me for this session from Durga Analytics.
Hello, everyone, and welcome. I'm your host from Durga Analytics, and I'm really glad you're here for this expert-grade training session. Today, we're continuing our journey to build production-level data warehouses with the incredible power of ClickHouse.
Now, just as a quick reminder, this session is part of our massive 340-chapter ClickHouse Mastery Bundle. This whole curriculum is designed to take you from the core concepts all the way to mastering things like distributed clusters and real-time data pipelines, basically everything you need for ultra-fast analytics in a real production environment.
So, where are we today? We're diving deep into Chapter 12, Aggregation Basics. This is a really foundational topic. It's right in Module 1, our Fundamentals module, and it's going to set the stage for pretty much everything that comes next.
And there's a reason we start here. You could say aggregations are the whole point of ClickHouse. They are truly the bread and butter of its analytical power. If you want to harness what makes this system so special, you've got to master aggregations first.
And when we talk about power, let's be clear about the scale we're dealing with. We're not talking about aggregating a few thousand rows, or even millions. No way. ClickHouse is built from the ground up to process billions of records per second. This is what enables real-time analytics on data sets that would simply crush traditional databases. So here's our game plan for this chapter. We'll start with the basics, the standard toolkit you probably already know. Then we'll get into grouping with group by. After that, the fun really starts. We'll uncover the ClickHouse superpowers. Then a super important pro tip on memory management before we wrap up and look ahead.
All right, let's start on familiar ground. We're going to kick things off with the standard aggregate functions. If you've written SQL before, these will look very familiar. And they're the building blocks for any analysis, including in ClickHouse.
First up, the simplest of them all, count. It does exactly what you think. It counts rows. But, and this is a big but, how you use it in ClickHouse matters a lot. And here's your first pro tip, so listen up. For the absolute best performance, you have to use count with nothing inside the parentheses. Just count. While count asterisk or count column will work, ClickHouse is incredibly optimized for the empty count. It seems like a tiny detail, but trust me, it can make a huge difference in your query speeds. Of course, we also have the usual suspects. Sum to get totals, average for the average, min and max for the extremes. But I want to pause on that last one. Any column. This one is a quiet performance hero. If you're grouping by something like a user ID, and you just need to grab one of their associated values, like an email address that you know is the same for all their rows, any email is way faster than min or max because it just grabs the very first one it sees. No comparisons needed. Okay, so we know the basic functions. Now, how do we apply them to different slices of our data? That's where the group by clause comes in. This is how we move from a single big answer to a much more detailed and useful analysis. I love this analogy. Think of group by like sorting laundry. You take your big pile of data and you sort it into different baskets based on, say, products category. Then you can run your aggregations, like sum of or count of, on each individual basket. It's a really simple way to think about partitioning your data for analysis. And here's a perfect example. We're telling ClickHouse, hey, first, sort everything by product_category. Then, for each of those categories, we want you to do two things. Count the number of orders and sum up the total revenue. The result? A beautifully simple summary of sales broken down by category. All right, we've covered the basics. Now, let's get into the really cool stuff. This is where ClickHouse leaves traditional SQL databases in the dust. We're talking about specialized, high-performance functions, what we call the ClickHouse superpowers.
Okay, so what if you need to count unique users? ClickHouse gives you two options, and this is a classic speed versus accuracy trade-off. You've got unique, which is blazing fast, uses very little memory, and gives you a really close approximation. It's perfect for things like real-time dashboards. On the other hand, you have unique exact. It gives you the 100% perfect number, but it's slower and uses way more memory. For most production cases, like tracking daily users, unique is absolutely the way to go.
So, think about this for a second. It's a super common business question. Which user made our single biggest purchase? In standard SQL, you'd probably be wrestling with subqueries or window functions. It can get complicated and slow, right?
Well, in ClickHouse, the answer is just beautiful. It's one function, argmax. You just tell it two things. First, the thing you want to find, in this case, the user ID. And second, the thing you want to maximize, which is the order amount. Boom. It finds the max order amount and returns the corresponding user ID. So simple, so powerful.
Another one of my favorite features is the if suffix. You can just tack this on to pretty much any aggregate function to make it conditional. This cleans up your queries like you wouldn't believe and makes them run faster by avoiding complex case statements.
For example, let's say you want to sum up the revenue, but only for successful transactions. Easy. Just use SUMIFAMOUNT status equals success. This lets you calculate multiple metrics like total revenue and successful revenue in a single pass over the data. It's way more efficient than filtering with a where clause for each metric.
Now for a really critical topic, especially for those of you running ClickHouse in production, we need to talk about managing memory during huge aggregations. This is key to keeping your system stable and reliable.
So here's the problem. When you do a group by, ClickHouse builds a giant table in RAM to keep track of the results for each unique key. Now what happens if you group by something with super high cardinality, like a user ID in a table with 500 million unique users? That in-memory table can get so big it eats up all your server's RAM, and then your query just crashes.
The solution, and your safety net, is a setting called max_bytes_ before external group by. Basically, you tell ClickHouse, hey, if this aggregation starts using more than, say, 10 gigabytes of RAM, I want you to start writing the temporary data to disk. Now, this will slow the query down because disk is slower than RAM, but, and this is the important part, your query will finish. It won't crash. And in production, finishing is what matters most.
And that brings us to the end of our deep dive on aggregation. Let's do a quick recap of the key takeaways before we look ahead to what's coming next.
Here it is, your aggregation cheat sheet. For counting rows, always use count. For fast, approximate unique counts, go with unique. If you absolutely need a perfect count, use unique exact, but watch your resources. And for clean, efficient conditional logic, remember to use those awesome if suffixes.
So far, we've seen what ClickHouse can do with aggregations. In our next session, Chapter 13, Query Execution Basics, we're going to peel back the curtain and look at how it does it. We'll explore the internal magic that makes these queries run so incredibly fast. It's going to be fascinating. I'll see you there.
Welcome, everyone. I'm with Durga Analytics, and today we're going to do something really cool. We're going under the hood to see exactly what makes a ClickHouse query just so incredibly fast. Let's get started. All right, so here we are. This is Chapter 13, Query Execution Basics. It's a really important piece of our first module on ClickHouse fundamentals. Truly understanding how queries are executed is absolutely critical because it sets the foundation for everything we're going to cover later, from advanced performance tuning all the way to distributed systems. So let's tackle the big question right up front. How on earth can ClickHouse tear through millions or even billions of rows with sub-second latency? Well, I can tell you it's not magic. It's a brilliantly engineered process. And in this chapter, we're going to pull back that curtain and break it down piece by piece. To really understand this, we've got a clear roadmap. First, we'll trace the 4-stage journey that every query takes. Then, we'll dive into the 2 secrets that give it that incredible speed: vectorized execution and massive parallelism. After that, we'll look inside the execution pipeline itself. And finally, I'll show you the command that gives you X-ray vision into this entire operation.
Okay, let's dive right in. The first thing to get is that every single query, doesn't matter how simple or complex, follows the exact same path from the SQL text you type to the results that pop up on your screen.
The easiest way to think about this is like an order in a restaurant. Step 1, parsing, is like the waiter taking your order and writing it on a structured ticket. That's what we call an abstract syntax tree. Step 2, analysis and optimization, is the head chef looking at that ticket and finding efficiencies, like figuring out which indexes to use so they can skip reading data they don't need. Step 3, plan generation, is the chef creating the exact recipe, the sequence of steps to make the dish. And finally, step 4, execution, is the whole kitchen staff firing up the stoves and running that plan on all burners at once.
Now, we're getting to the first real secret weapon. This is a fundamental concept that just completely separates ClickHouse from a lot of traditional databases, and it's a huge reason for its amazing performance. So here's the difference. Traditional databases often process data row by row. It's slow, and there's a ton of overhead for every single little value. ClickHouse avoids all that by processing data in big chunks called blocks or vectors. It actually uses a special CPU feature called SIMD. That's single instruction, multiple data. It means one operation, like addition, can be applied to a whole vector of values all at once. It's the difference between hammering in 1,000 nails one by one versus using a nail gun that drives them all in with a single, super optimized action. The second secret is just massive parallelism. A lot of older systems are single-threaded, meaning one query gets one CPU core. ClickHouse was designed from the very beginning to completely saturate every core on a modern multi-core CPU. Let's go back to our kitchen analogy to see how this works. First, the data gets split into a bunch of chunks, kind of like the head chef splitting a huge order into separate dishes. Second, each of those chunks gets processed at the same time by a different chef, or in our case, a different CPU core. And finally, all those partial results are merged together to create the final answer. It is just a massively efficient way to work. And this right here is the key takeaway. You really need to get this. More cores equals more speed, and it's an almost perfectly straight line. If you double the number of cores on your server, you can pretty much expect your query performance to double too. For scaling your analytics, this is an absolute game changer. So we've got these 2 big ideas, vectorized processing and parallel execution. But how do they actually get orchestrated? How does the data flow between them? Well, that brings us to the execution pipeline. ClickHouse uses something called a pull model. It's actually really elegant. At the very top, you have the aggregator stage, and it requests a block of data. It pulls that data from the expression stage below it, which in turn pulls from the filter stage, which then pulls blocks of data straight from the source, the actual data files on disk. This demand-driven flow is incredibly efficient because each stage only does work when the stage above it asks for data. It's a smooth, seamless pipeline.
Now, all this theory is fantastic, but what you really want to know is how you can see this in action with your own queries, right? Well, this is where you get your superpowers. The explain command, this needs to become your best friend. As a professional, anytime a query is running slow, this is your first diagnostic tool. It completely eliminates all the guesswork and shows you the precise execution plan that ClickHouse came up with. Now, it's really critical to understand the 2 main ways to use this command. Just typing explain gives you the high-level logical plan. Think of it like the chef's recipe notes. But explain pipeline,
That gives you the detailed, physical plan. This is where you see exactly which columns are being read, how many data parts are getting scanned, and how all the stages are connected. For serious performance tuning, mastering the output of Explain pipeline is a must-have skill. So let's wrap this all up. The secret to ClickHouse's speed isn't just one thing. It's a whole philosophy of being obsessed with minimizing overhead at every single step. It does this by processing data in these efficient vectorized blocks and by throwing every single available CPU core at the problem, making sure your hardware is used to its absolute maximum potential. Now, a huge part of this efficiency is making the data as small as possible before it even gets to the CPU. In our next chapter, Chapter 14, we're going to explore compression fundamentals and see how ClickHouse uses powerful algorithms to make your data incredibly light and lightning fast to read. I'll see you there. Hello and welcome, everyone. Today, we're diving into a really crucial aspect of ClickHouse performance, something that a lot of folks get wrong. We're talking about compression. And if you think it's just about saving a little disk space, well, you're missing out on its biggest benefit. We're about to explore why it's actually the key to unlocking some serious query speed. Now, just to place us, this session is part of a much larger series from us here at Durga Analytics. It's a comprehensive 340-chapter curriculum designed to get you completely production-ready with ClickHouse for real-time analytics. We are right in the middle of Module 1, building up our core knowledge. Specifically, we're in Chapter 14, all about compression fundamentals. So let's get right into it. I want to start with a question, really a challenge to a common assumption. You know, if you've come from other database systems, you're probably hardwired to think that compression is all about shrinking your data to save on storage costs. In the ClickHouse world, that's really just scratching the surface. Here's the most important thing to get straight right from the beginning. In ClickHouse, compression's #1 job is to make your queries run faster. Period. Saving disk space, that's just a fantastic side effect. The real win, the main event, is performance. And it all comes down to one thing: reducing disk I/O. So why? Why is this so different? To really get this, we need to talk about the biggest, baddest bottleneck in almost any analytical query you'll ever run. Let's just imagine for a second. Say your query needs to scan a 10 gigabyte dataset, okay? Without compression, the system has to physically pull all 10 of those gigabytes right off the disk. There's no way around it. Okay, but now let's apply a pretty typical 10x compression ratio. All of a sudden, the system only needs to read 1 gigabyte from that disk. Now you might be thinking, wait, doesn't the CPU have to work to decompress that data? And yeah, you're absolutely right. It does. But here's the magic. Modern CPUs are insanely fast. They can decompress data orders of magnitude faster than even the quickest SSDs can read it. We're making a fantastic trade, a tiny bit of CPU time to save a huge amount of time waiting on the disk. And this right here is where ClickHouse's columnar architecture becomes a total superpower. Because it stores data by column, you get these beautiful, homogeneous streams of data. All the integers are lined up together, all the timestamps are next to each other. This structure is what makes those mind-blowing 10x, 50x, sometimes even 100x compression ratios possible. And every bit of that compression translates directly into faster queries. So now we get the why. It's all about performance, performance, performance. Let's shift gears to the what. What tools does ClickHouse actually give us to manage and control this whole process? ClickHouse gives us a really clear choice between two main general-purpose algorithms. First, you've got LZ4. It's the default for a reason. Its focus is pure speed. Decompression is so incredibly fast that the CPU almost never becomes a bottleneck. It's perfect for your hot, frequently queried data. Then you have ZSD. ZSD is all about density. It'll give you a much better compression ratio, which makes it an awesome choice for cold data or archival data, where squeezing out every last megabyte of disk space is your main priority. But wait, it gets even better. On top of those general algorithms, ClickHouse lets you apply specialized codecs. Now, think of a codec as a smart pre-processing step that actually understands the kind of data it's looking at before the main compression algorithm kicks in. For example, with a column of timestamps, the Delta codec is brilliant. It doesn't store the full timestamp every single time. It just stores the tiny difference from the previous one. This is how you can get really surgical with your optimizations. Okay, so the theory is great, but theory alone isn't going to cut it in a real production environment. So let's look at how this all comes together in a practical, real-world table definition. And, just as importantly, how we can check that our choices are actually working. Take a look at this create table statement. We're not just picking one compression setting for the whole table, no way. We're applying a chain of codecs, column by column. For our timestamp, we first run it through the Delta codec to handle that predictable sequence, and then we wrap that result in the fast LZ4 algorithm. For the floating point reading column, we use the specialized Gorilla codec, and again, wrap it in LZ4. This is granular, column-level control at its finest. And the best part? You never have to just guess if your strategy is paying off. ClickHouse makes it super easy to check your work. You can just run a simple query against the system.columns table, and it'll give you a detailed report card on how well everything is being compressed. And when you run that query, this is what you get. A nice, clean, unambiguous report. It shows you the compressed size, the original size, and that all-important final compression ratio for every single column. I mean, look at that category column, a 54:1 compression ratio. That is a massive performance gain, just sitting there, waiting to be unlocked. So if there's one thing to take away from all this, it's this. You are always managing a balance between your CPU and your desk. You have to make a conscious choice based on your workload. Do you want to trade a little more CPU for maximum disk savings with CSTD? Or do you prioritize lightning-fast query speed with LZ4? The right answer is always going to be specific to your data and how you use it. We've seen now that compression just loves well-organized homogeneous data. That just naturally leads to the next question, doesn't it? How can we physically arrange our data on the disk to make our compression even more effective? And that is the perfect setup for our very next chapter, where we'll be talking all about partitioning concepts. We're going to explore how physically organizing data into logical buckets, say by month or by region, builds directly on these compression fundamentals to make everything even faster. I'll see you there.
All right, welcome back everyone to the Durga Analytics ClickHouse Mastery course. We are on this massive journey together, all 340 chapters building truly production-level data warehouses. Today, we are digging into an absolutely critical piece of that foundation, partitioning. So just to get our bearings, we are still deep in Module 1, laying down all the ClickHouse fundamentals. And today's session, Chapter 15, tackles one of the most important concepts you'll ever learn for performance and managing huge amounts of data. Let's get right into it.
So, let me ask you a question. Does this sound familiar? You have these huge tables, maybe billions, even trillions of rows, and the queries that used to be snappy are now just crawling. And when it comes to cleaning up old data, it's a total nightmare, a slow, resource-hogging mess. If you're nodding your head right now, then you're about to see the solution.
To really get this, I want you to picture a giant warehouse. And on the floor is a massive, disorganized pile of millions of documents. Now, if I ask you to find one specific document from last March, what do you have to do? You have to search through the entire pile, piece by piece. That's a full table scan. And it's exactly what ClickHouse has to do with a big, unpartitioned table. It's just brutal. So, partitioning is our solution to this chaos. It's like we bring in a giant digital filing cabinet. We take that one massive table and we physically split it into smaller, much more manageable chunks. We call these chunks partitions. and each one acts like a perfectly labeled drawer in our cabinet, say one for January, one for February, and so on.
Now, this is super important. Do not get partitioning confused with sorting. We've talked about the order by key, right? Think of that as organizing the files inside one of those drawers, like putting them in alphabetical order. It helps you find things faster once you're in the right drawer. But the partition key, the partition by, that's what labels the drawer itself. It tells ClickHouse which drawers to even bother opening in the first place. It operates at a much higher level.
So how do we actually build this filing cabinet? It's surprisingly simple. It all happens right in your create table statement with the partition by clause. You can see the example here. Partition by to YYMM event time. This little line tells ClickHouse, hey, for every single row that comes in, look at the event time, figure out its year and month, and then stick that row into the correct physical directory on the disk. That one declaration sets up the whole system. Okay, so we've built this amazing digital filing cabinet. So what? What can it actually do for us? Well, it turns out it has 3 incredible superpowers for managing data at a massive scale.
First up, partition pruning. This is huge. When your query has a where clause that filters by month, ClickHouse gets super smart. It looks at the query and says, aha, I only need to open the drawer for March 2023, and it completely ignores everything else. The speed boost is just dramatic. Second, efficient deletion. Forget slow delete statements. With partitioning, you can just say drop partition. It's like taking a whole drawer and tossing it out instantly. And third, easy data movement. This is key for managing costs. You can take your oldest drawers, say data from 5 years ago, and move them from your expensive fast storage to cheaper cold storage seamlessly.
Let's really look at that deletion superpower in action. Check out this command, alter table sensor logs drop partition 2023-01. This targets all the data for January 2023. And this isn't a slow row-by-row grind. It is a metadata operation. It's like flipping a switch that tells the file system that directory is just gone. It takes milliseconds, even if that partition held terabytes of data. It's a game changer.
Okay, now for a really, really important warning. Because while partitioning is incredibly powerful, if you do it wrong, it can cause huge performance problems. And the number one mistake I see beginners make is something called over-partitioning.
Let's go back to our filing cabinet. Imagine taking that idea and just going crazy with it. You decide to create a separate drawer for every single piece of paper. You'd have millions of tiny drawers. It's not organized anymore, it's pure chaos. The overhead of just managing all those drawers would grind everything to a halt. That's exactly what happens in ClickHouse. It creates so much metadata overhead that it actually cripples performance.
So what's the sweet spot? This table breaks it down perfectly. Partitioning by month? Excellent. By week? Also pretty good. You'll end up with a few dozen, maybe 100 or so partitions. Daily? Now you're getting into risky territory. Over a few years, that's over 1,000 partitions. And partitioning by something with high cardinality, like user ID? Never. That's a classic anti-pattern that will absolutely wreck your system. The rule of thumb is to aim for total partition count in the low hundreds, not thousands.
All right, so this all sounds great in theory, but how do you know if your own tables are healthy? How can you pop the hood on your own filing cabinet and make sure you're not heading towards that too many parts danger zone?
Well, ClickHouse gives us the perfect tool for this, the system.parts table. This query you see here should be your go-to health check. It queries that system table and groups everything by partition. It tells you, for each of your drawers, exactly how many physical data parts it's made of and its total size on disk. Running this gives you instant insight into whether your partitioning strategy is working or if you have a problem brewing.
So, let's bring it all home. What's the bottom line here? The crucial point is that smart partitioning isn't just some neat query trick. It is a core, fundamental strategy for data lifecycle management. Getting it right enables blazing fast queries through pruning and gives you the tools you need for efficient data retention and storage tiering. It is absolutely essential for managing data at scale.
And believe it or not, we're just getting warmed up. Partitioning is the first pillar of query optimization. Think of it as getting ClickHouse to the right aisle in the warehouse, instantly. In Chapter 16, we're going to see how we combine this with sorting keys and indexes to find the exact specific data you need on the shelf with surgical precision. It's going to be awesome. I'll see you there.
Welcome to this session from Durga Analytics. If you're building production-level data warehouses with ClickHouse, you know that speed isn't just a feature, it's everything. So in this explainer, we're not just going to talk about fast queries. Nope, we are going to build the blueprint for achieving them, right from the ground up.
Just as a quick reminder of where we are in our journey, we're in Module 1, the Fundamentals, and this is Chapter 16, Query Performance Basics. Now, what we're covering here isn't just theory, okay? This is the core knowledge you absolutely need to build truly high-performance systems. This is the foundation for everything that follows.
I love this quote because it really gets to the heart of the matter. This is the core philosophy we're going to unpack today. Performance isn't something you just hope for after the fact. It's something you design into your tables and your queries from the very, very beginning.
So here's what we're going to tackle. First, we'll talk about the golden rule, the single most important principle. Then we'll see how ClickHouse actually finds its data, which is super interesting. After that, we'll cover some practical tips you can use right away. And finally, we'll learn how to diagnose a query that's still running slow. All right, let's dive in.
Okay, the foundation of all query performance in ClickHouse, the one idea that everything else builds upon, it can all be summarized in one simple, powerful rule.
Your primary goal, always, is to minimize the amount of data ClickHouse has to read from the disk. That's it. Everything else we discuss, every single optimization technique, ultimately serves this one objective: read less.
First up, let's talk columns. You have got to avoid select star. You just have to. In ClickHouse's Columnar world, every single column is its own separate file on disk. So think about it. If you select 20 columns when you only need 2, you're forcing ClickHouse to open and scan 18 extra files it never needed to touch. That's a huge waste.
And for rows, it's the exact same principle. Scanning an entire table is incredibly wasteful. The solution here is to use your sorting key, what ClickHouse calls the primary key, right in your where clause. This allows ClickHouse to be amazingly efficient, which actually brings us to our next point, how it finds your data in the first place.
So how does ClickHouse use that sorting key? Well, it's not with a traditional index like you'd find in something like MySQL or Postgres. ClickHouse does something completely different, and frankly, it's a key reason for its incredible speed.
So instead of a detailed turn-by-turn street map that points to every single house, think of the sparse index more like a highway map. It only shows you the major exits. This lets ClickHouse look at the map and basically say, hey, I don't need to get off at any of these next 50 exits, and boom, it can skip scanning millions of rows in a single step.
Now this is the crucial point, so listen up. Your where clause has to use the columns from your sorting key in order, starting from the left, just like a prefix. So if your key is country, date, user ID, filtering on country, super fast. Filtering on country and date, also super fast. But if you try to filter only on user ID, that's going to be much slower because it can't use the first part of that index to skip all that data.
And this leads us to a core design principle. When you define your table, you want to put the columns with low cardinality, the ones with fewer unique values like country, first in your order by key. Why? Because this maximizes how many huge blocks of data ClickHouse can just skip entirely.
Okay, so now that we have that foundation, reading less and using the index correctly, let's look at a few more high-impact techniques that you can apply right now.
This one is big. Please always filter with where before you aggregate with group by. See, aggregations happen in memory, and they use a lot of CPU. By filtering first, you drastically cut down the amount of data that even enters that expensive aggregation stage. It's simple. Process less, go faster.
What's really cool here is how you can see the impact rating of different techniques. Using an indexed filter, which is exactly what we just talked about with the where clause and the sorting key, that's a 5-star top-tier optimization. And right behind it is partition pruning. That works at an even higher level, letting ClickHouse ignore entire folders on disk if they don't match your query. These are your most powerful tools, for sure.
But what happens when you've done everything right, you think, and a query is still slow? Well, at that point, you need to stop guessing and start diagnosing. You've got to play detective.
Look, when a query is slow, the problem isn't some vague, abstract slowness. The issue is that you are overwhelming a specific system resource. And performance problems, they almost always come down to one of 3 specific bottlenecks.
Think of it like a factory, right? Is your production line slow because the raw materials aren't getting delivered fast enough? That's a disk I/O problem. Is one specific machine totally overworked and just can't keep up? That's CPU. Or have you just plain run out of physical space to assemble your product? That's a memory bottleneck.
And the great news is that ClickHouse gives you the exact clues you need right there in the query summary. If it read 1 billion rows to return just 10, well, your where clause isn't using the index correctly. If it read 50 gigabytes of data for a simple count, you're probably selecting way too many columns. These 2 metrics tell you exactly where to start looking.
Ultimately, query performance in ClickHouse isn't about magic. It's about precision. It's about designing your tables thoughtfully and writing your queries to be incredibly specific. You just have to tell the system exactly what you need so it can do the absolute minimum amount of work and read the absolute minimum amount of data.
So we've covered the rules for writing these precise queries, but the most powerful tool isn't just writing the code, it's seeing the impact. Our next step is to explore ClickHouse's system tables. Think of them as your server's crystal ball. And the next chapter, we're going to learn how to stop guessing and start seeing what's actually happening under the hood.
Welcome back to the Durga Analytics ClickHouse Mastery Course. In this session, we are unlocking one of the most powerful features you'll ever use in a production environment, ClickHouse's own internal diagnostic system. We're talking about the system tables. These are your window, your crystal ball into the health, performance, and real-time behavior of your database. Just to quickly show you where we are on our journey, we're deep in Module 1 building up all that crucial foundational knowledge. Right now, we're on Chapter 17, and this is where we really start moving from theory to hands-on practice by digging into ClickHouse's built-in observability. So let's get started. So here's our game plan for this chapter. First, we'll talk about this idea of a self-aware database. Then we'll open up what I call the mechanics toolkit to see how we can investigate things that happened in the past, monitor what's happening right now, and even check on the system's physical health before we wrap it all up. Any production database can often feel like a total black box, right? Queries go in, answers hopefully come out, but when things slow down or worse, break, how do you actually see what's happening inside? This is the fundamental challenge we all face as developers and administrators. Well, ClickHouse has a really brilliant solution for this. It comes with a special database literally called System that logs and tracks absolutely everything about its own operations. We're talking metadata, performance metrics, query history, server stats, you name it. It's not a black box. It's what we call a self-aware system, and the tables inside are our crystal ball for figuring out any issue. The absolute best way to think about the system database is like a mechanics toolkit that comes built right into the engine. Just like a high-performance car has that onboard computer telling you everything about engine performance, ClickHouse has specific tables designed for very specific diagnostic jobs.
Okay, our first, and you could argue most critical tool, is the system's flight recorder. Think about it. When something goes wrong in production, a report is suddenly slow, an ETL job fails overnight, you need a detailed history to figure out what happened. This is always your starting point for investigating anything that's already occurred. And the main tool for that is system.querylog. This table is your absolute source of truth for historical performance. It captures every single query that was executed, and more importantly, it logs all the juicy metadata you need for tuning: how long it took, how much memory it used, how many rows it read, and who ran it. Seriously, this isn't just a log, it's a performance tuning goldmine. So let's make this practical. Your users are complaining that the system feels slow. Instead of just guessing, you can run a targeted query against the query log, just like this one here. You'll notice we're filtering for finished queries and then sorting by duration. This gives you immediate, data-driven proof of your biggest performance hogs. So historical analysis is awesome for doing a post-mortem, but what happens when the problem is happening right now? A runaway query could be eating up all your CPU this very second, dragging the whole system down for everyone. For those moments, we need to switch from our flight recorder to live telemetry. And our next tool gives us exactly that, a live process monitor. It offers a real-time, up-to-the-second view of every single query and background task that's currently active inside the ClickHouse engine. This allows you to jump in and take action the moment a crisis hits. And that tool is the system.processes table. If you've ever used the top or htop command in Linux, you'll instantly get why this is so valuable. It shows you exactly which queries are running, who kicked them off, how long they've been going, and how much memory and CPU they're gobbling up. The workflow here is super straightforward. You run a select on system.processes to see what's happening live. If you spot a query that's been running way too long or is using way too many resources, you grab its query ID and use the kill query command to stop it in its tracks. This is exactly how you handle performance emergencies in real time. Okay, so we've covered query performance, but now let's pivot to the physical layer and talk about system health. The way your data is actually organized on the physical disk is a huge and often overlooked factor in your overall performance. For this job, we need our storage inspector. This is the tool that lets us peer beneath the surface, beyond the logical table, and see exactly how ClickHouse has laid out the data into physical files on your storage. The system.parts table is what gives us this incredible visibility. It shows you a row for every single data part, which are the actual immutable files ClickHouse uses to store your data. We can see which table a part belongs to, its size, its status, everything. A really common performance killer in ClickHouse is having way too many small parts, and this is the table that will tell you if that's happening. And here's how you check it out. This query groups by table and gives you a count of all the active data parts, plus the total size on disk. If you run this and you see a table with thousands or even tens of thousands of parts, ding, 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 you very likely found a major area for optimization. Now, beyond those big three, our toolkit has a bunch of other essential sensors. System.columns is great for inspecting your schema. System.metrics gives you that high-level server health dashboard. System.clusters is absolutely vital for distributed setups. And System.tables can even give you the original create table query. You know, for when you've lost it, we've all been there. So a pretty logical question should be popping into your head right about now. If System.querylog records every single query, isn't that table going to get massive? And the answer is yes, it absolutely would. But ClickHouse is really smart about this. It has a built-in automated management system to make sure these diagnostic tools don't become a performance problem themselves. Here's how it works. It's pretty clever. First, log rates are buffered and then written in batches to cut down on I/O pressure. Second, the log tables are partitioned by time, usually by month, which makes querying recent data super fast. And finally, there's a time to live or TTL policy that automatically deletes old log entries to reclaim disk space. It's basically a self-cleaning oven. All right, let's bring it all home. What have we covered? These system tables, they're not just nice to haves. They are an essential onboard diagnostic toolkit that gives you complete operational visibility into your entire ClickHouse environment. Here's the key takeaway, plain and simple. For past performance, you go to query log. For current live issues, you check processes. For physical storage health, you inspect parts. For a quick health check, you look at metrics. And for any kind of failure, system.errors is your starting point. If you master these 5 tables, you can diagnose almost any issue you'll ever run into. So, as we've seen, that system.parts table is incredibly important, and our diagnostics often point us to problems with merges or having too many parts. And that really begs a fundamental question, doesn't it? What exactly are these data parts that are so central to how ClickHouse performs? And that is the perfect setup for our next chapter. In Chapter 18, we're going to do a deep dive into understanding data parts. We'll explore exactly how these immutable files get created, how they get merged together, and why their unique design is really the secret sauce behind ClickHouse's incredible speed. I'll see you there. Welcome to Durga Analytics. If you're serious about building a production-grade data warehouse with ClickHouse, there's one concept that you've absolutely got to master, and that's the data part. It is the fundamental unit that really governs ClickHouse's legendary performance, and today we're going to dissect it completely. Now, for those of you following our full curriculum, just a quick reminder, we are in Module 1, Chapter 18, which is all about understanding data parts. And look, this isn't just theory. What we're about to cover has a direct impact on everything from your query speed to your storage footprint. So let's get right into it. So let's start with the big question. In most databases, right, there's this painful trade-off between how fast you can write data and how fast you can read it. But ClickHouse just seems to defy this logic. I mean, how can it possibly ingest millions of rows per second and still spit back query results in sub-seconds? Well, the answer comes down to a single, elegantly simple concept, the data part. You can really think of it as the physical atom of your table. Everything about ClickHouse's amazing speed and its architecture, it all starts right here. Here's how it works. When you run an insert statement, ClickHouse doesn't go searching for some existing file to add data to. Nope. Instead, it creates a brand new, completely self-contained directory right there on the disk. That directory is the data part. It holds everything, the compressed column data, the primary key indexes, all of it, just for that one specific batch of inserts. And this is the most critical detail of all. Data parts are immutable. Once that directory is written to disk, its contents are never, ever modified. This simple rule is what eliminates the need for all those complex file locks, and that is the secret behind ClickHouse's incredible performance when writing tons of data at once. Okay, so an obvious question comes up, right? If every single insert creates a new directory, won't my disk just fill up with millions of tiny little folders? I mean, that sounds like a total performance disaster. And you'd be right, except for this. This is where the life cycle of a data part becomes so important. Let's take a look at the merge process. Let's just walk through a scenario. You insert, say, 10,000 rows, and poof, part A is created. You insert another 10,000 rows, and now you have part B. In the background, completely automatically, a merge process kicks in. ClickHouse reads the data from both parts A and B, combines them, sorts them, and writes a new, bigger, and much more optimized part C. And what happens to the old ones? Well, parts A and B are marked as inactive, and after a short grace period, they get deleted. And that continuous background process of merging smaller data parts into larger ones, that's not some random feature. It's the core function. In fact, it's exactly why the most common table engine in ClickHouse is called merge tree. The name says it all. Now, if you've ever queried the system.parts table in ClickHouse, you've probably seen those really long, kind of random-looking directory names. Well, guess what? They are not random at all. Each part of that name tells a very precise story about the data it holds. Let's break one down. Imagine you see 2026-03-152. The first part, 2026-03, that's your partition key. So in this case, it's data from March of 2026. The next two numbers, 1 and 5, represent the minimum and maximum data block numbers inside this part. And finally, that last number, 2, that's the merge level. A higher number here means the data in this part has been through more merge cycles. You can literally diagnose the health of your table just by learning to read these names. So, okay, how does all this internal knowledge translate into our actual jobs as architects and engineers? Well, understanding data parts isn't just academic. It has direct and honestly critical performance implications. One of the most common issues that new users run into is the dreaded too many parts error. This is what happens when you insert data in really small batches really frequently, like one row at a time. You just end up creating new parts way faster than ClickHouse can merge them in the background. And to protect itself from getting totally overwhelmed, ClickHouse has this built-in safety net. By default, it will stop accepting new inserts for any single partition once it hits more than 300 active data parts. And just to be clear, this is not a bug, it's a feature designed to prevent your whole system from grinding to a halt. So the takeaway here is really simple and frankly non-negotiable for any production system. The wrong way is inserting data one row at a time. The right way is to always batch your inserts. You should be aiming to group at least 1,000 and ideally up to 100,000 rows into a single insert statement. This creates fewer, larger parts, which is just vastly more efficient for both writing and querying. Okay, so the whole idea of immutability brings up another really practical question. If the files can't be changed, how in the world do you handle operations like delete or update? ClickHouse handles this using a process called a mutation. Now, when you run a delete, it doesn't go find the row and just erase it. Instead, it rewrites the entire data part, creating a brand new version that simply leaves out the rows you wanted to delete. As you can probably guess, this is a heavy, resource-intensive operation, and it's something you should really use sparingly. So let's just quickly summarize the key mechanics. Immutability, that gives us those high-speed, lock-free writes. The merging process, that keeps our query performance consistent and fast. Mutations let us do updates and deletes, but they come at a high resource cost. And finally, that inactivity period for old parts, that's what guarantees that your long-running queries won't suddenly fail just because a merge is happening in the background. All right, we have covered a lot of ground. So let's just boil it all down to the key takeaways you absolutely need to remember. Just remember these 4 things. 1. Every single insert creates a new, immutable part. 2. The background merge process is your best friend. It keeps the system healthy. 3. Always batch your inserts to avoid that too many parts error. And 4. Treat mutations as heavy operations, not something you'd use for transactional workloads. With this deep understanding of the storage engine, you have now mastered the core theory. So it's time to move from the why to the how and actually put all of this into practice. In our next chapter, Chapter 19, we're going to apply all of this theory as we build our first real analytics workload, ingesting and querying millions of records. We will see you there. Welcome back. Okay, this is where the theory stops and the real work begins. In this chapter, you're going to architect and build your very first production-grade analytics workload right here in ClickHouse. We're taking all those fundamental concepts we've talked about and putting them to the test to solve a real-world business problem. Now, before we dive in, let's just get our bearings. This is Chapter 19, and it's basically the grand finale of Module 1, ClickHouse Fundamentals. everything we've covered in our big 340-chapter journey, from architecture to data types, has been leading right up to this moment, this critical hands-on exercise. So here's our game plan. We'll kick things off with a classic e-commerce challenge. Then you'll see exactly how to architect the table for just insane speed, generate a massive data set to act like it's under production load, and then, the best part, we'll pull out the kind of real-time insights that actually drive business decisions. Let's get started. All right, let's set the scene. Imagine you're the lead data architect for a massive global e-commerce platform. The business needs you to track every single user event. We're talking clicks, views, purchases, everything in real time so they can understand what users are doing and make snap decisions. This is the core problem we need to solve. Not thousands of events, but millions of them, just streaming in constantly. The business can't afford to wait hours for some batch report. They need answers right now. This right here is the exact high-volume, high-speed analytics workload that ClickHouse was born to handle. So where do we start? Well, your first and most important step is designing the table for speed. In ClickHouse, a smart schema isn't just, a nice-to-have. It is the absolute foundation for getting that interactive, sub-second query performance we're about to see. Okay, take a look at the Create Table statement on your screen. This is our blueprint. We're using the merge tree engine, which is the absolute workhorse of ClickHouse. We partition by month to help manage data over time, but the most important part, look at that order by key. This isn't just for sorting your final output. This literally defines how data is physically laid out on the disk. By ordering by event type, country, and date, we're telling ClickHouse to cluster similar data together. That means our queries can just read these tiny, specific ranges instead of scanning the whole table. That's the secret sauce to ClickHouse's speed. And here is a fantastic optimization trick you need to have in your back pocket. See that low cardinality string wrapper? Think of it like this. It creates a secret internal dictionary for columns that don't have a lot of unique values, like country or device type. So instead of storing the full string desktop millions and millions of times, ClickHouse just stores a tiny little integer and uses a lookup table. It's an incredible way to save space and make filtering and grouping on these columns ridiculously fast. Excellent. We've got our high-performance table structure, but right now it's empty. So let's move on to step 2 and give this engine some fuel to burn. We're going to simulate a real production environment with a ton of data. Now, just look at this single command. We're not loading some clunky CSV file. Nope. We're using ClickHouse's own built-in functions to generate a really rich, randomized dataset completely on the fly. By selecting from the numbers system table, we can just instantly create millions of rows of realistic-looking data in one shot. This is such a powerful feature for developing and testing. And just like that, you have 5 million rows in your table. Let's just pause on that number for a second. With one simple command, you've created a dataset big enough to bring a lot of traditional databases to their knees. For ClickHouse, this is just a warm-up. And it's ready for analysis right now. Okay, this is it. This is the payoff. You've done the hard architectural work, you've loaded up the data. Now it's time to ask those critical business questions and see the kind of millisecond performance that makes ClickHouse an absolute game changer for analytics. So, imagine a request lands on your desk from the marketing team. They need to know right now the top traffic sources from the last week so they can adjust their ad campaigns. This is a classic time-sensitive business question. And here's the query to get that answer. It's just clean, standard SQL. But notice we're filtering by event date and grouping by country, the very same columns that are in our order by key. This means ClickHouse knows exactly where to look to get the answer, making it super efficient. And there's our answer, a perfectly clear ranked list of countries by their total events. The marketing team now has actionable intelligence, and they got it instantly. That's business win number 1. All right, next up, the product team wants to know where the money is coming from. Are people buying more on their phones or on their desktops? This insight is going to directly impact what they work on next. To answer this, we write another simple aggregation query. We're grabbing the device type, summing up the purchase amount, and, critically, we're filtering just for purchase events using the event type column. And since that's the very first column in our primary key, this query is just unbelievably fast. And again, the results are immediate. We have a crystal clear breakdown of total revenue by device. Now the product team can make smart, data-driven decisions. That's insight number 2, delivered in a flash. Okay, now for a more advanced question. We need to calculate the conversion rate. This is probably one of the most fundamental metrics for any e-commerce business, right? It tells you how good you are at turning window shoppers into actual customers. Now, the thing to see here is the COUNTIF function. Honestly, this is a ClickHouse superpower. In other databases, you might need complicated subqueries or multiple passes over the data to get these numbers. But with ClickHouse, you can do this conditional counting for both views and purchases in a single, super efficient pass over the data. The whole conversion rate is calculated right there in the select clause. It just doesn't get more efficient than this. And this is the final result. Just look at that timing, 12 one-thousandths of a second. This is the direct result of every smart design choice you made at the beginning. The merge tree engine, the partitioning, that all-important order by key, and those low cardinality types. You just ran complex aggregations across 5 million rows, and the answer came back before you could blink. This is the power of ClickHouse. It turns analytics from a waiting game into a real-time conversation with your data. And with that, mission accomplished. Seriously, congratulations. You've just successfully designed, populated, and queried a production-grade analytics workload completely from scratch. So let's just quickly recap what we achieved. 1, we designed a high-performance schema using specialized types. 2, we instantly generated 5 million rows of data. And 3, we ran complex, real-world business queries that came back in milliseconds. This is the blueprint for doing real-time analytics. You've just finished your first full, hands-on project, which is awesome. In our next session, Chapter 20, we're going to tie a bow on everything you've learned in Module 1 with a comprehensive fundamentals review. This is going to make sure you have a rock-solid foundation before we move on to the really advanced topics like distributed clusters and complex table engines. I look forward to seeing you there. Hello and welcome to Chapter 20. You've officially reached a huge milestone in our 340-chapter journey to making you a production-level ClickHouse expert. You've just wrapped up the entire first module, and in this explainer, we're going to do a full fundamentals review. We're going to lock in everything you've learned and make sure that base is rock solid before we move on. And seriously, what a module it was. You have officially completed Module 1, ClickHouse Fundamentals. That's no small feat. You've laid all the essential groundwork, going from the absolute basics all the way to understanding what it really takes to build high-performance analytics systems. And you know, this isn't just theory. You've already put this stuff into practice. You've successfully built, loaded, and queried a 5 million row analytics workload. That is a genuine, real-world achievement. So before we jump into advanced architecture, let's make sure we've got the core pillars that made that possible completely locked in. Okay, so here's our game plan for this review. We're going to start with the conceptual core, the why behind ClickHouse's speed. Then we'll hit the architectural pillars, the how it all works. After that, we'll go over the queries and tools you've mastered, and we'll finish up with a quick readiness check before we look at what's coming next. First up, let's revisit those fundamental concepts. This is the big why behind ClickHouse's incredible performance. And let me tell you, really getting these ideas is absolutely critical before we try to build anything more complex on top of them. Right, the most crucial distinction we learned is between OLTP and OLAP. Remember that bank transfer analogy? An OLTP system, think of a traditional database, is great for the transaction itself. making sure one transfer happens correctly. But an OLAP system like ClickHouse is built for something completely different, the analysis. It's for looking at the history of millions of those transfers to find patterns, all at lightning speed. And that brings us to the secret sauce, columnar storage. This is the absolute core reason ClickHouse is so ridiculously fast for analytics. By storing the data for each column in its own separate file, ClickHouse can just ignore the files for any columns you don't ask for in your query. That's the magic trick. That's how it skips reading massive amounts of data from the desk. Okay, now let's build on that concept. We're moving from the why to the how. Let's review the architectural pillars, the internal mechanics you've been working with, basically the engine under the hood. One of the most clever parts of this whole architecture is the sparse primary index. Let's go back to our phone book analogy. Instead of having an entry for every single name, which would create a gigantic index, it just marks the start of each page, or granule. This brilliant design keeps the index incredibly small and fast, so small, in fact, that it can fit entirely in your computer's RAM. You also learned all about the life cycle of your data. See, every time you run an insert, ClickHouse isn't actually modifying an existing file. Nope, it creates a brand new, unchangeable data part on the disk. It's like a self-contained folder with its own data and index files. Then later, a background process comes along and merges these smaller parts into bigger, more optimized ones, which is what keeps the system running nice and healthy. So we've covered the why and the how. Now let's review the what. The practical, hands-on skills, the commands, and the tools you've learned to use to actually interact with and manage your ClickHouse instance.
I want you to really think about this for a second. Based on everything we've just talked about with columnar storage, what is the one command that just completely undermines its biggest advantage? What is the number one enemy of performance?
That's right, select star. It seems so harmless, doesn't it? But in a columnar database, it is an absolute performance killer. And why? Well, because you're forcing ClickHouse to read every single column file from the disk, completely throwing away the benefit of being able to skip the columns you don't need. Being specific with your select statement is always the first rule of optimization.
And look at the toolkit you've built up. You're now comfortable with the command line client, you've poked around in the web UI, and you've learned how to query the incredibly powerful system database. You can monitor performance with system.querylog and check on your table structure and health with system.parts. These are essential tools. Think of this table as your go-to cheat sheet for all the key actions you've mastered. Want to speed up a query? You know to filter on an indexed column. Need to save disk space? You use Codex. Trying to manage data over time? You partition it. And if you ever see that too many parts error, you know you need to batch your inserts. It's that simple. All right, we have reviewed all the core concepts. Now it's time for a final check. Let's just run through a couple of quick questions to really solidify this knowledge and make sure you're feeling confident and totally ready to tackle the advanced topics coming up in Module 2. First question, and let's get specific. Why is select star so much worse in ClickHouse than in, say, a row-based database like MySQL? Well, a row-based database stores all the columns for a single row together, so it has to read that whole chunk of data anyway. But ClickHouse has to individually go and open and read every single column file from the disk, which is just a ton more work. Question number 2. Think about that data parts lifecycle again. A background process merges small parts into a new, bigger, more efficient part. What happens to those original small parts? Well, they get marked for deletion, and then a few minutes later, they're completely removed from the disk. This makes sure your data isn't duplicated and all that space gets reclaimed. And for our final question, this one really gets to the heart of good schema design. When you're defining your table's primary key using order by, should you put a column with very few unique values first, or one with millions of unique values first? Think about how that choice affects compression and data skipping. The answer is
You should always place the column with the lowest cardinality, which just means the fewest unique values, first. Why? Because this physically groups similar data together on the disk, which leads to dramatically better compression and allows that sparse index to skip massive chunks of data way more effectively. It's a game changer. And with that, you have officially completed the fundamentals review. You now have a solid, practical foundation in how ClickHouse works from the inside out. The only question left is, what's next? Well, in Module 2, starting with the very next chapter, we are leaving the basics behind. We're going to dive deep into advanced architecture, we'll explore storage internals, replication for high availability, and the principles of designing a distributed cluster that can handle petabytes of data. Your foundation is set. Now, we're ready to really start building on it.